Hey everybody. Hope you're doing well. Hope you're doing real well. We're playing some Factorio today. Should be a good time. If you didn't catch it, we had a recap video go out on YouTube of the previous stream. Pretty proud of it. Very highly produced, highly edited. More so than anything that I've ever put out before. So yeah, it's pretty good stuff. Let me I just want to make sure that I can just test it like this. I want to make sure that I can record so that I can get the next edit out. So give me just 1 second while I work on that. Let's see, should have a bunch of these. Delete. Alright. And then if we push this button, we're recording, in theory. Source record for the game capture and the webcam microphone thing. Yes. Let's see if it's working. I know the webcam's working. Okay, there's the webcam. Looks like the game record is not working, so we'll fix that. Give me a moment. Give me a moment. Let's go to filters. Yes, that makes sense that it's not working. On a source record. Record no, stream no, audio track, different audio track, track free, gameplay, game audio, there we go. Let's, hold on, just copy filters, paste filters. And this just has to go to, hold on. We're very, yeah, it's all very formal and official here on the stream. Gameplay source. That. You go there. There we go. Title it as such. You can't see anything I'm doing, so from your perspective, I'm just mumbling to myself. Great content. Good job, Max. Good content. Game audio. There we go. Okay. Now we should be good. And if we hit this button, yes, gameplay is recording as well as face. Okay, let's play some Factorio, ladies and gents. We are picking up where we left off, which was after building our little mall here. We've got some stuff going on. We've got some backups. We've got 100 inserters now. Gonna pick those up and start this whole process up again. Got some of those, got some assemblers, got some belts. Should be able to just boop. There we go. Fully loaded out for the next phase of our plan for world domination. What do we need to do that is the question. What is the plan? What is the plan indeed? I'm a little bit curious about more technologies for inserters. They're dated behind Logistics 2, it looks like. Capacity bonus, long inserters. Allows inserted range to be configured, rotation configuration, more rotation configuration. Okay, let's go down this route. I'm curious about getting more adjustable inserters stuff going on. because I think that'll speed us along quite nicely. Also, it would be good to... we've got assembly machine 2s now, which means we can make landfill with sand instead of stone. I think we start doing that. Let's do that. We'll make one of these. Easy enough to make since we have the assembly machine Mark 1s in our inventory now. Gonna put this here. And load. And this is just, your purpose is landfill with sand and water. And then we need some pipes. Okay, there's an electric pole in the way, that's fine, there we go. There, now we have landfill automated. That was easy, huh? And it is limited by the amount of sand we can crush here, but it'll just build up over time. We don't need to worry about it too much. I wish this was faster. I do. Wow, that really takes all the sand. Okay. It is a better ratio than without water and just from stone, because 1 stone becomes 2 sand. Which means each of these wood recipes is taking 5 stone. I'm just 3 wood. It's like 10%, so yeah, it's like half a stone versus a full stone. I think it's still better to use the greenhouses for those sciences than it is to use other things. Let's see. Burner labs, we need iron for that. Okay. I should automate those. That would be nice. Single cylinder stone brick. We've got stone bricks here. And single cylinders. I mean, this is, like, I'm proud of it. It's a cool little setup, but it is messy, I will say. I think the first thing we do is just we handcraft some of these, and then we expand our, nope, not that much. We expand our iron and copper mining and smelting operations a little bit. 1, 2, 3, 4, 5. Gonna double science consumption is the plan. And I can improve this from 0.5 to 0.75, so it'll go from per 40 seconds to per 30 seconds. So from per 8 to per 6 per assembler, which would be kind of nifty. Alright, it is getting dark. I think it's time to, you know what we should definitely automate is lamps. Those are not difficult, and I want a lot of them. So let's take a look-see here. There's iron and copper right here. And if we can get glass through here somehow, then that'll be that. Alternatively, just want to keep things illuminated. Alternatively, we could route it like through over here on the right side of the mall. That's an option. Or we could just set up a little ad hoc station like down here just for lamps. It's not a great idea. No, better would be to get the glass up here somehow. So how are we gonna do that is the question. I don't know. I don't know how we're gonna do that. Let's get a little bit of light in here. Nice to be able to see. We could just handcraft as well, that is an option. It's not a great option, but it is an option. No, it's we're definitely going to we're gonna move this all. And then check out what happens here. Oh, I am standing in the way. There you go. So basically, the plan is to insert far away, like that, and we will be able to, should be able to get rid of these. Yeah. Cleaning things up with our newly available medium electric poles. And we want to make sure that we've got everything like this, and then these can hand off between them, which is kind of cool. There we go. Drop far. Drop far. No, pick up here, drop there. There we go. You need to drop far as well. You drop far, and those might need to get replaced with fast inserters, but that doubled our science consumption right there, and then we can just keep trailing this down the way. And eventually we can inject the next science, probably military, on this side of the belt, and then it's fed with 4 sciences. And then we'll need to redesign it before we move to 5 science or more, but that is okay. That is okay. Alright. Now, let's, what were we doing? Lamps. Let's get some lamps automated. That's the plan. How is the question. I don't think I've left myself any space to weave a belt through here. There's a little space here, maybe? Maybe. Let's clear some space here. Almost, but no. Here? No? Ah, boy. How are we gonna do this? I guess we split it and we bring it this way. Because this can be brought there. There we go. Alright, and then like this. And like this. Alright, there we go. Now we've got glass, more or less, we can get it on the belt here, which is what we need. And the spaghetti increases tenfold. There we go. Alright. So now glass is over here. We've got iron there, copper there, and glass here. And I want... we don't have... that's fine, I'll just use an iron chest. Alright. Now then. We need... yeah, that's fine. Because we need copper cable over here. So that's done. Now it needs iron plates and it needs glass. Like that. And then pick up from there, and with our adjustable inserter powers, we now have lamps. Get 2 stacks of those. Slowed down by that. Can I... and it keeps its configuration. That's nice. There we go. Now we're building lamps. Most important building in the game. Gotta be able to see. Okay. Next up, Our iron production is sorely lacking. So let's get that dealt with. We need more miners for that. Small electric, iron gears, burner inserters, or burning mining drills rather. Single cylinder stone brick iron plate. Why does that sound familiar? It doesn't. Never mind. Okay. There's single cylinder iron plate. Single cylinder is gear wheels and iron plate, so we would need one of these, one of those, one of those, something like that, and then we could, but we'd want it up by one, something like this. Alright. Some weird stuff could happen here if we wanted it to. I know what to do. Okay, so this is going to be gear wheels. This is a little bit ridiculous. Gonna boop one of those. Here. There you go. Now we've got a inserter. Not totally happy with this, but it'll do. We need those gear wheels in here, as well as the iron. Something like this. That'll be single cylinders. Again. We've made several copies of those at this point. What's going on here? There you go. Then those need to be placed on a belt like this. This is an insane build. This is not. It's not good. Okay, drop off there. So stone bricks will go there. Single cylinders will go there. And this becomes these. I guess we need to go like this. Okay. My Q key is sticking on my keyboard, which is annoying because Q is used a lot in this game. But it's okay. Alright, and then, I mean, while we're spaghettifying, why not just spaghettify all the way, right? Iron gear wheels into small electric motors. Seems simple enough. Could just do something like this, and then how hard is it to make small electric? Iron gear wheels, copper cables, iron cables, or iron plates. Okay. Pick up from there and put here. That's gear wheels. And something like this will be these. And that needs gear wheels as well. So it's going to be gear wheels, something like this. That needs copper wire and iron plate. Pick up, no, like that. And then we just need copper wire, which we can do like this. Splitter. Like that. Oh, it's getting real ridiculous, guys. This is gonna be a real ugly build. Please, Q key. Okay, I'll need to fix that. It's copper wire. Okay. Something like this. And an intermediate copper wire. Copper cable is actually what it's called. And electric motors goes there. It's a lot of copper cable. Okay. Stop. Let's load. There you go. Don't think we need that to be a loader. That can be an inserter. This needs more iron gear wheels, which just needs the correct pickup location to be manufacturing. And all right, it's real rough spaghettification at this point, but it is working. Oh boy, it's not working because of this. That's fine. There we go. Now we have electric miners automated. That is ugly. Very ugly. We're making it work, okay? We're gonna make it work. Alright. Let's see. This music is stressing me out. Next song, please. Better. A little bit more hype. A little bit less, whatever that was. Hey, Logistics 2 is researched. That's great. That means we can get fast underground and stuff. We're not doing that with this current mall setup. I have a plan. I have a plan for the inserters, which I will, or for the whole mall, which I will show you later. It's going to require kind of a replacement of this whole situation, but I think it'll be worth it. Alright. We've got some mining drills now. 6 of them. And I think that's our bottleneck. Well, it's part of the bottleneck. It is. Yeah. We can just get Electro Dread, increase the anxiety, but to a beat, indeed. That is what we were listening to. It wasn't on purpose, but it was what we were listening to. Alright, there we go. Iron mining is... I'm gonna turn that down a little bit. Oh, that's not... That was scrubbing instead. Okay. Oh! Did the game crash? Okay, that was weird. Don't know what just happened. Doesn't seem like anything crashed. Hello? Alright. We're gonna need to do a little bit more forethought now to get everything wired up. Alright, this should get us more iron for sure. Yeah, and now we need some of the red belt so that we can increase our iron smelting. Alright. Oh ho ho! Look at this! Oh, this is cool. Okay. Okay, so now we can make some truly ridiculous designs. Because they can output on an angle. This is dumb. Like, you could have one here and output to a machine right next to it. That's crazy. I'm so excited to play with that. Alright. Let's see. So red belts are exactly twice as fast as yellow belts. And it looks like we are saturated on output? It's a little confusing. Oh, I guess it makes sense. Okay. Yeah, but red belts are twice as fast as iron belts, so you can pack things twice as compact on red belts as iron belts. I said yellow belts. I think I might have said that, but I'm losing my mind already today apparently. Okay, let's think about how we want to do the mall in the future, right? The future of the mall, the future of all assemblers. So for instance, we've got transport belts, right? I want a belt running down the middle with whatever things need. Let's talk about this. This would require single cylinders and iron plates. But we can do things like, for example, pick up from there, drop to there, and now that will grab belts from here and put it into the red instead, which is super cool. And then that would just need to be single cylinders and iron plates on a belt. Gears. Trying to puzzle it out here. Let's think about all the things we want to build, right? We want to build a lot of things. Now, there's a way to do this that is interesting. And that is, we could do it with sushi. Or, hold on. Like, because that one could feed all of those, right? So, like, if we pick up from there and drop off to there, and we pick up from there, yeah. Oh, it's gonna get weird, guys. It's gonna get real weird. It's gonna get really weird. Okay. Interesting. So if that's a belt, then all the things that require belts could be fed off of that. So like that could be our, like that, for instance. And instead of that whole kerfuffle, it would just be this. And then we would have iron, so that we could do something like this, because both of these require gear beams, right? Iron beam. That requires gears, that requires gears, so those would both get a gear assembler. And then single cylinders, so that would, yeah, because we would need, okay. Pick up from there. This becomes a gear assembler, or no, this becomes a single cylinder engine assembler. That requires gears, which is already fed. Okay, interesting. This also requires gears. As does that, I guess, but that's fine. Something like this. And I don't know what we would make here, but it would be cool. I kind of want to put this up like this so that it's symmetrical. Okay, interesting. What would we put here? I don't know yet. But this little block contains everything that we're doing in this whole space here. You see what I mean? And then where do we need iron? We need iron there, 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 and there. Okay. So, what if we do one of them like that, and then we could go like this. and like that. Okay, there we go. And this goes here and here and here. Then we need outputs, which could be weird if we wanted them to be. What was this supposed to be? Loaders? Yeah. This is so cool. Okay, okay. This is an insane layout. And then we just need to, that could move so that we could have, there's a lot of things we can do with this. Okay. Okay. I'm excited. I'm excited about this. Let's look at the next more inserters requires space science. So we're not going to be there anytime soon. Okay. Next, let's get walls researched, followed by steel furnaces, so that we can do what we need to do here. Okay, so now, let's say that this is out. Because I can drop there, and then this can drop there for an output, and finally, how are we gonna get this out? I just want it all to come out this way. And then it's just a single iron line, and that's all of the belts. What are these looking like? Transport belt, normal underground, normal splitters. Okay. So actually, this is all going to need to be torn down because I'm going to need to think about the next upgrade. That's what this game is, though. It's all about iteration. You can keep playing the music if you would like. Media request plugin. Thank you. Okay, so iron comes in, copper comes in, stone comes in. Anything else? Wood, I guess. We might need wood for something, but I can't think of anything. We'll say iron, copper, and stone come in for now. And we want to make the most compact design that generates everything we've made here plus the next tier up. Okay. So, for that, one way to do that would be to use what's called a sushi belt. And the way that sushi belts work in Factorio is essentially you use circuit conditions to detect how much of each item is in the overall system and only allow items in when there's space for them, essentially. That's one thing we could do. So the easiest way to do that is like this. Something like this. Let's say we have 3 inputs, right? Stone, copper, and iron. And then we let's get a green wire, get a bunch of deciders, arithmetic, yeah, something like that. And then it'll output onto this belt. like this. Okay. Then it becomes sushi, in that we can take things off of the belt and put them back onto the belt. Like this. And we can wire all of these inserters together to tell us how many of each we need. So, could do it on both sides very easily. And we need, for instance, inserters. Need 8 assemblers, as we determined in our last stream and video. So, let's think about this. If we want inserters, inserters need burner inserters, which need inserter parts, which can go here, and single cylinder engines, which can go here. Gonna want to be smart about how we do this. These need to be gear wheels, definitely. So this will pick up from here, drop off there. This needs sticks as well, so that'll have to be sticks. So iron comes here. Then burner inserters go there. But we don't actually need to output burner inserters because they're only used in one recipe. So instead, they will go like that. Okay. That's burner inserters. Then small electric engines, or automation cores. Okay. Those require copper, which we will have on the belt because we're sushiing it. And they require sticks and gear wheels, both of which are already on the belt. That's easy. These require gear wheels, iron, and copper cable. Copper cable. Okay. You are actually going to be copper cable instead. And the music has stopped again. Okay. And you're gonna go here and here, except no, you're going to here and here, pick up from there, drop off to there. There we go. And you'll pick up and drop off like that. And you'll just drop off like that. Okay, so that whole mess right here, from here to here, all gets simplified into this right here. With some circuit conditions and such, but it does leave space for lights, which is nice, I guess. Yeah. Okay. Light there, light there. There we go. We should be able to pick up some now. They should be crafted. Okay, automated, excuse me. Having a hard time with my words today. I don't know what I'm trying to say. Forget it. We'll move on. We'll move on from that thought, apparently. There we go. All in 2 of those. Sweet. Alright. Then we need to actually wire them all up. and enabled if, and then we need to do like a memory cell. It's been a while since I've done this. Something like this. And we want each greater than 0, output each, input count. Okay. So then that gets wired here. No. Try again. It gets wired with red wire. Okay. So now, as things pass, it will read the contents from those belts. Which we need to read the contents, read the contents, and read the contents, and it will increase the amount in the overall belt by that amount. You know what we need to do, actually? We need to not read these belt contents. We need to read the next one. So we can go like this, and that just has to read the belt contents. There we go. Okay. This doesn't make sense yet. Don't worry. I'll explain more. Alright, so let's say that we want 50 iron. Hello, iron? Resources. Okay. Let's say iron plate less than 50. You are going to be copper plate less than 50. And you are going to be stone less than 50. Or stone brick. Does anything here need raw stone? Not yet. We'll say stone brick. Which is in logistics, actually. Yeah. Stone brick less than 50. There we go. Heavy armor's crafted, by the way. We can go ahead and make that once we have enough steel for it. Okay, so how is this actually going to work? It's going to be a loop. So this will go this way. And it'll keep those items in the loop. And then every time an inserter picks something up, it will output a negative value of that item. So every time one of these picks something up off the belt, we want it to output a negative value of that item. Okay. So, let's actually disconnect that, and it's going to be a combinator outputting each times -1, output each. Okay, and then this is just going to read hand contents. Don't enable disable. So that will pulse. Signal is sent for 1 tick. Signal is sent continuously as long as the insert is holding. Just pulse. And then we need another memory cell, which will take the output of that, and it'll say for each greater than 0, output each, input count. Okay. This should work, theoretically. Things should be removed from the belt and then we can test it. We don't have a way of actually subtracting that. Right. We need to get that back into the input of that. So that's going to be a green wire. Like so. There we go. I'm not sure if this is going to work. We're going to try it, though. And the way we're going to try it is with loaders for now. So, if we load copper and iron on this belt, we should get inserters. And we need to, and we need to read the contents of the red. Hold on. We need to read these contents like this. The reason for that is that we have to disable the output inserters when there are enough of each item. So it'll have to read hand contents and enable disable. Read as a pulse. Enable when less than, let's say, 20. Okay. And this doesn't have an output yet, but that is okay. We can very easily output it wherever we want, really. Not quite wherever we want, as it turns out. That's okay. Let's just do it like this for now. There you go. Now we should be able to make a stack of inserters like this. So we need to, first of all, and then just change all of these signals. Right? You are set to just read hand signal. Wait, that shouldn't be connected. Hold on. Oh yeah, it should be. Okay, there we go. I've done a dumb. Hold on. We need to look at this. Outputs is what we're looking at. Okay. And then you are enable disable, but you need to read hand contents. You need to be none. Okay. So that reads, outputs, that remembers. Let's try it. Here we go. So there should be some amount of those, some amount of, look at this, it's working. It's keeping track of everything that's in the system. And it's decreasing when the iron is picked up. Oh, it's cool. It's really cool. And then the iron comes back around, and more stuff is assembled. We're waiting on gear wheels, apparently. That's fine. Let's put in more iron and copper. Now copper enters the equation. And it's allowed to get picked up, but not too much of it enters. And now some copper wire is on the belt. Some inserter parts are being manufactured, I'm noticing. And we need more of these. It does take some time. It does take some time. It's not the fastest. I mean, if we wanted to speed it up, we could basically make more gear wheel assemblers, and that would speed things up. And it does release iron in batches, it seems. But it is working, just slowly. This is really cool. I've never actually built one of these systems, and I'm quite pleased by it. It just there's something really fun about this. I think we need to make that a fast inserter, and maybe that will improve things a bit. Because we're definitely lacking gear wheels. Does this keep the circuit conditions? It does. Okay. So now, anytime there's iron on the belt for us to take, it is getting input into gear wheels first, which is great, because we need a lot of them. Still waiting on electric engines. And that is because, oh, I see. We need to actually remember to set these automation cores, iron sticks, inserter parts, single cylinder engines. Okay. That would do it. If you forgot to set all of your filters, it might do that. And this needs to be small electric. Okay, let's clear the belt, which is something you do need to do occasionally with sushi belts if you're not careful. Let's grab a few stacks of iron and copper, and let's feed them through and see what happens. There we go. 4 stacks of each, iron and copper. That should be enough to make like a full stack of inserters. All right. Iron. Copper. All right. Oh, and then I forgot to flush the contents of the... Okay. You also have to reset the memory cell. Which we can do just by breaking that connection. But, hold on. Let's get all this stuff cleaned up first. Yeah, we can just I really want to set this up from scratch here. Hey, we did make an inserter. That's pretty cool. Okay. Shouldn't have anything. Memory cell should be blank. There we go. Iron and copper in the system. Iron belt is now turned off. Gear wheels are going in. It's 3 stacks of each. Iron's coming back around now, which means gear wheels will be able to be produced again. And we could speed this all up by speeding up the belt to a red belt for the whole loop. That's a thing that we could do. Alright. It does take more time than a normal system, that's for sure. Mostly because you have to wait for everything to go through the full loop. But waiting on automation cores, which are waiting on gears. These take all the gears. Okay. Let's see what happens when we speed this up. Handcrafting some red belts here, just to speed things along. We do have some automation cores joining the loop now. I think it might just take some time to get up and running. I think honestly the problem is I only have one gear wheel machine. One of the problems with this masterpiece of a design. Could I add more of the basic parts builders on the top side of the loop? Yeah. Yeah, we absolutely could do that. We can expand basically any part of this system as many times as we want, actually. Let's see. Looks like our output for gear wheels is also a little limited, so I'm going to speed that up. There we go. Now we're making gear wheels as fast as this machine can make them. Which is not as fast as the whole system needs them necessarily, but it is still pretty speedy. Let's get more of these. Oh, we do have 4 inserters though. So that's cool. All these are going to have to be fast inserters, realistically. Especially things that require something like 6 copper cables. That's going to have to be a fast inserter. Output of copper cable is probably a fast inserter. Then the other thing I could do, as far as output is concerned, is I could just output it straight onto the belt, count it, and then put it in a chest. That's another thing that we can do, and probably will do eventually. We're all the way up to fluid handling already, eh? There's gates. Give me multi-cylinder engines. Give me large containers. Let's just research all the things, shall we? Trains are on the horizon. This is working. We are making inserters from this system. That's cool. What do we have in the system right now? We have copper. We do not have enough iron, which makes sense. We do have the single-cylinder engines, and once those are backed up and buffered, it won't. Once everything's backed up and buffered like that, it won't. What am I trying to say? It won't make more of them. So then all of the gear wheels, for instance, will continue to pass down. Will continue to pass down the road. So, for instance, we have enough single cylinders, and we have enough inserter parts now, and we have enough copper cable. So now we're just waiting on automation cores and electric engines. So those are taking the entire surplus of resources at this point. Okay. So this works. Kinda works. Then we just need to, we can expand this loop however long we want, basically. Or zigzag it, or however we want to do the loop, as long as it loops back to itself eventually, we can do. Which is cool. Can you, like, yeah, you could output from there and input onto the belt immediately in front of it. That's kind of cool. Let's do that. We're actually going to hook this thing up now to the system that we already have. There you go. Iron's in. Then copper is in. And now this will just run as fast as it wants to. Then we're going to make some fast belts, I have decided. So let's make some belts. Everything for these belts is already on the assembler. And we just need to make sure the wire continues. Kind of want to put it there, though. No, I'm correct. Because it grabs from... No, it grabs from later, puts down before. So it should grab here, put down there. So... Doesn't actually matter for these ones, now that I'm thinking about it, but... It's all good. Okay, we want some fast belts. We also... But actually, let's put these down here, and let's make these, at Kat's suggestion, gear wheel assemblers instead. Then we just need to make sure they are wired correctly. So input and output, which go to here. Actually, we can just limit those by gear wheels. There we go. And then this can be something like this. And we want to place take. Come on. There we go. Need more cable. Which will go like this. And you're going to be belt. And you are going to be red belt. Yeah. And then, to get the belt, to get whatever we want off of the, this is cool. To get whatever we want off of the belt into a chest, we can set the whitelist for this based on a circuit condition. So we can basically have a constant combinator, which tells us how much of everything we want. So let's say we want 100 yellow belts, let's say we want 100 red belts, and let's say we want 100 inserters. Then, basically, we just need to subtract the number in this chest with, and the number on the belt. No, we just need to subtract the number in the chest from the constant combinator. And then we have our, okay, then we have our filter. Trying to get too fancy with it. Let's grab an arithmetic combinator here. We already had one. That's fine though. Alright, now we go here. Oh, input, hold on. We need 2 of these. No. Yes, we do need 2 of them. Like I said, it's been a minute since I've done this. There we go. One of these needs to be -1. I think this each times -1. And then we can just set filters. Each... No, we only need 1 of these. What am I doing? We just need to multiply that by -1. There we go. Multiply each by -1. Okay. So now it has its filter set. And you can see if we just grab a wire off of this so that we can see how many of each. It's 100 of each, but these will go to 0 when we have enough in that chest. And then we just need to read hand contents of that like we do here. So read hand contents on a pulse and send on the red line back to because it's taking them off the line. There we go. Okay. Now, we just need to make everything we need here. And now those should join the... That can pick up from far. But it needs to do this. It needs to be one of these. So go like this. And this is inserters. Okay. Okay. Sweet. It's working. And now you can see that it is not working. Hold on. Input signals each times -1, output each. There we go. Now it's working. You can see in the, right above my camera, the green inserter signal is now 99 instead of 100. Once that hits 0, this will be turned off, which is cool. What are we waiting on here? We're waiting on you to output? There we go. And we can see on this line that inserters are now joining the belt and getting picked up. And you picked up a random... Oh, you're getting the red. Okay, hold on. We need to cut this off for a second. Because you're getting random signals. It's still working, kind of, but it is messy. And the reason it's getting messy signals is because these are set to read hand contents, so it's getting 1 frame pulses of the hand contents of those. What the heck? Why aren't you set correctly? You're set correctly. There we go. Yeah, it's getting random pulses of the hand contents of all the other things, which we can fix just by saying instead you will read your hand contents. You're set to read hand contents still, yes. And you will read each times 1 and output each. And this is just making a one-way yeah, this is just making a one-way signal, basically. So it's still telling the overall system that it's taking things off the belt, but it's not picking up signals from that system anymore. This is working. Like, this is actually working, which is super cool. Alright, now let's speed up the belt more. And we can expand this however much we want, basically. And you can see already that it's a much it's a much more elegant design than what we did last time. I mean, last time worked and will continue to work as much as we want, but this is just so much easier to expand. We can just place as many layers of this as we want, and then that's all we need to do. As long as we leave enough space for this to go like this, we can do that whenever we want, and then this is our mole, which is pretty nifty. This can be placed basically anywhere. We could in fact place it over there instead, which would mean we could put another assembler here, making something if we wanted to. Alright, where is our bottleneck now? There we go. Red belt all the way around. It's beautiful chaos, isn't it? I'm curious to see... I'm curious to see what'll happen when this fills up. I just want to see it work. You can see that yellow belt above me there is at 32 now, which means that, yeah, this should work. It should go to 0 and then it should stop. We can also set the stack size of this to 1 if we want, with a circuit condition. Which will prevent it from going into the negatives. Which is, I mean, I don't know if it even matters. I think it'll turn off even if it's negative. Belts are almost filled up here. I love this game. I'm just having too good a time staring at this right now. This is great. Oh, yep, now it won't pick up belts anymore. Because the belt's filled up. And if we look in here, we should have exactly 100 belts. Look at that. System works. And then, I mean, we can expand this however much we want. Like, if we want to input steel into this system, we can at any point. This is not where it's going to live permanently, but I figured this is where I would put it for now. Okay. Okay, now where are you? You are going to that line. So we just want this to go here and multiply each by -1 and output each. And then this is going to have to be quick if we don't want to screw it up. So we're going to... We could also power switch it. The other thing you have to be worried about with a sushi belt setup is just the overall bandwidth. You can think of it like memory. You want to make sure you don't overfill the belt because you need space to put things back down on it. This would... There you go. Interesting. Now that's not connected to anything anymore? Yeah, because we want to multiply that by -1 and then send it... Oh. Hold on. Send it there. There we go. Now things are being removed from the belt correctly again. That probably screwed up the count a little bit, but it's okay. Let's just rotate that so it looks a little cleaner. There. Now we can put another one here if we want, doing whatever we want it to do. And because it's a loop, it can do literally anything we want it to do. This could be one of the last items, one of the first items. It's position agnostic. So that's pretty nifty. The only thing I would love for this to have is a smart way to drain everything off the belt, remember, and then put it all back on the belt and add it back to the memory cell. Okay, what are we missing here? We're missing iron gear wheels. Why? Because it says we have gear wheels, but we definitely don't. Okay, that's fine. Let's get everything off the belt. We're going to drain it ourselves, and then we're going to clear the memory. But we're also going to do a little redesign here while we're thinking about it, because this could be better. Basically, I want this to go this way instead, and then can have 2 layers like this. And then we can have more assemblers here if we want. And I'm sorry, spaceship, it's time. Nope. I usually leave this here for posterity. So the question then becomes, are we actually going to tear down all the stuff we made last time and rebuild it with the sushi mall? Is that the play? No, we don't have... Hold on, we can probably make one. Yeah. There you go. Yeah, maybe. Maybe. Let's go with belt. And we're gonna... read hand contents none, perfect. And then we need to... and this is going to be belt less than 20 now. There's... it says there's 20 on the belt. Oh, I haven't actually... oh, I should have kept that. Oh well. There we go. System's back up and running. Then we want this to be, let's go with splitters. Undergrounds require iron beams. Underground loader. Fast transport belt. Okay. Can I, like... F? Is it R? I don't remember how to... It's okay. We'll probably need to drain this belt again anyway. Excuse me, by the way. Okay. So now... like that. And it would be sweet if we could move this power pole to here. And I guess that'll have to be how that works. We're not turning those on yet on purpose. Okay, and then this is going to be output. Oh boy. That's alright. There's some extras. We can clear the memory cell. That just needs to be put on here. And that's going to be inserters. And then that is annoying. But fine. Nah, I'm not happy with that. Hold on. Let's do that. And this is gonna go over. Except not like that either. Like that. Ugh. It's the wiring's gonna be gross here. Okay, we're gonna redo the wiring, I think. Because this is gross. Yeah. Nasty. Alright, let's cut power to this whole shebang. Oh, that was a mistake. Don't cut power. Instead, we'll just... Alright. How are we gonna do this? Those are output belts, which need to be read onto the line. So we'll make those red. Like that. Hold on. Just unplugging all of this here. And it's going to break the whole system for a second, but I'm okay with that. Okay. Get everything unplugged. There we go. Alright, so now we need the inputs. Let's see. We're going to output belt red. Don't care about that. Output belt red. There we go. Need more cable. Okay. And then we're going to input belt green, or input inserter rather green. Okay. Now we've got red and green, and we can simply output both the red and the green onto the cables, which can carry signals, as we've seen. Then red becomes output, and green becomes input. There you go. And now it'll just kind of daisy chain its way around. Or actually it'll just be on that side and then run down the lanes. Which is fine. Okay. So all that's done. Now we need to actually map them. And it's going to be red from that side goes to red from that side. So let's do that. And then green becomes red. Like that. There we go. then whatever we want to add to the belt, we can. Alright, and you are none read hand contents is the green ones. And the red ones have requirements. And it's however many we want on the belt in rotation. So, for instance, you are going to be iron beams, but you're going to be a lower amount of iron beams. Or a higher amount of iron beams, rather. Let's say 40. You can say 40 as well. Okay. 40, let's say underground belts, 10. And let's say loaders, 10. And let's say fast belt, 20. Sure, why not? Okay, why is that like that? Because of that. Okay. There we go. And then we just need to drain the belt one more time and turn it back on, and all these things will be available. And then remember, we can set however many of each of these we want with this constant combinator here. So like, I want 50 undergrounds, and I want 20, or I want 50 splitters, for instance. And let's say I want 50 loaders as well. Why not? Then that sets that input, and it'll bring them to me. Now we just drain the line. Okay. And we turn on the memory cell. Now everything should kick off. And right now we only have one gear factory still. So everything might be a little bit slow. Will be a little bit slow. But we can very easily expand gears like this. And we just need to run a red cable. Let's just now we've got 3 gear assemblers up here, adding to the overall gear manufacturing. Helps if we have a green wire. There we go. Love to see it. Looks like that might be should still be looking for those. It's not picking them up for some reason. It's picking up belts and stuff. So... why are you being weird? Input signal 91. Output signal negative 91. And then that's adding... that should still be working. Okay. You're getting the addition of those. It's weird. That is weird. I'm not sure why those aren't getting picked up. Guess we'll see in a second. Waiting on belts for you. Belts are waiting on single-cylinder engines. Single-cylinder engines are waiting on a slow inserter. Okay. And this doesn't have to be super, super fast or anything. Because it just stockpiles over time. That's its purpose. I guess it can only have 4... Interesting. It can only have 4 at a time. So then my inserter should be turned off now? Yeah. Because we have 20 inserters floating around in the system. So it can only have 4 filters at a time, meaning that it takes the highest 4, like what do we have the demand for the most. Which is kind of cool, because it means you won't fill up just one at a time. You'll fill them all up kind of equally. So that's cool. So now it should take an inserter? No. Fascinating. I guess it'll probably take an inserter once it's filled up on underground belts. Just one more craft of undergrounds now. Yeah, now it'll probably take inserters again. Yeah, okay. So it chooses its filters, and then it takes those things, and then it moves on to the other things. So now that that's happened, our inserters have gone down, and we should see that they go back up, because this should have turned on. It did. It's missing single cylinders now, or it's missing electric engines, which are missing copper cables, which need a faster output. Oh, no they don't. There's enough on the belt, apparently. Really? Yeah, I would believe that there are 20 of those on the belt. Alright. Well, this is kind of cool. I enjoy this quite a lot. It's another way to do them all. Like, I mean, ours works too, but is a lot bigger than this. A lot bigger than this. What are we not making here that we are making over there? Lights, assemblers, and electric poles. Okay. And that's the power of circuit conditions. We can do this in a much lower... it's much fewer like tiles. It's a much smaller space. It's much more compact, and it's really, really cool. So this is probably how we'll be doing this from now on. We can get some stone bricks in here, and then we can make assemblers and stuff. And we could expand it out this way as well, to make basically anything we want. It makes it kind of slow. What are we missing? We're missing single-cylinder engines. So to fix that, we could just have another single-cylinder engine. Waiting for space in the destination. Yeah, we'd want another single-cylinder engine. What if I set you to near? Does that help at all? Not really. Okay. What if we... I don't want to enable disable there. It's probably fine. We'll just have to add another assembler down the road, and we'll have to watch out for bandwidth issues as well. You can help the bandwidth somewhat by like splitting the belt and then remerging it. It can slow things down substantially though. By that I mean we could have like a splitter here, like here and here, and then just run another belt in parallel here. Which is what I'm going to do. Now the count is off again, by the way. And we'll have stone, which means that we could make circuits on site with stone tablet and copper cables, because stone tablet is just one stone brick makes 4. Yeah. That's pretty good. There you go. See, and that acts as like a buffer already, and then we can spiral that way to expand them all as much as we want. So like this, we'll just make little banks of 10 assemblers here. And this will be way easier once we have construction robots, because then we can have them build it for us. We don't have assemblers in this particular mall yet, but we will soon, actually, now that I think about it. So let's do that. Cutting those off will cut off... I really wish I had a better way to wire all of these, really. That's the only thing that is kind of missing from this design. But it is okay. So what do we want to build? Remember that this will go around this way, so these will be the first ones touched. So we're going to have stone brick. So we're going to want assemblers. So let's get assemblers. Assemblers require burner assemblers. Burner assemblers require stone brick. That's super easy. Okay. Let's get some electronic circuits on the line here. Let's get some electric poles on the line here, and medium electric poles, which we already have everything being built over here. See what I mean about how like just simple it is to expand this. So now if I wanted these, those are done. And if I want those, well, now those are done. And if I want those, well, now those are done. Because we already have all of the pre-existing components on the belt, and I can just, boop, there they are. Way easier. Way easier than having to route belts everywhere and thinking? None of that for me, thanks. Once. I'll do the thinking one time to set up the initial circuit condition. But that's it. That's all the thinking you're getting out of me, sir and or madam. Alright, let's figure this out. It's gonna go in, out, out. And then we're gonna have the red cable go to our outputs. Yes, it is truly efficient. Q key, why are you so sticky? What happened to you? Alright, I'm gonna have to do some surgery here on my Q key. Give me a moment, guys. Grabbing the rubbing alcohol, this is ridiculous. I can't find the rubbing alcohol. I will find it, though. We need it. Badly. I'll be right back. Maybe I should be an actual... I'll be a good streamer and enable my BRAP backstream. Screen. There we go. Boop. Be right back. Meow, huh? Where did it go? Where the alcohol went? We've got some other more different cleaner instead because I couldn't find the straight alcohol, so hopefully it doesn't break my keyboard. Okay. Oh. Great. There we go. Maybe. We'll see. Seems good. Hello! I've returned. Music, it would be great if you would not stop playing over and over again. It's not. It just stops between songs. Well, that's not good. Now my Q key is constantly held down. I'll grab some paper towels. Okay. Yeah, it's just when it transitions to the next song, sometimes it breaks. Oh boy. We've caused problems. Hold on. We will remap Q to something else for now. Let's do like... I don't know. Okay, I can still move, but my Q key is like pushing other buttons as well as Q, and it is just always being pressed. So that's not great. Okay. On the plus side, it's not sticky anymore. Going to try to disable the Q key in IQ software and see if that will help us at all. And then I don't know what else to do there. Oh, it sounds like fluid chemistry finished. That's good. There we go. And I'll have to do some keyboard maintenance off camera. Device not found. Okay. Are we back? Is it working? Maybe. Yeah, it seems to be working. Okay. There. Okay. Q key is now disabled in software. And we can play the game. Oh. Q key was disabled in software. Alright, it looks like we can play the game. Oh boy. Yeah, we can clear our cursor with other ways. Factorio indeed! Welcome to the stream, Jimbo. How you doing? Yeah, we will have to we will have to note that in the recap video for sure. Now, what is going on here? Have we caused problems? No, it looks good. Okay. Oh my God, I'm gonna have to. Ooh. Okay. Oh boy, it's causing me some problems for sure. Alright, we're just gonna have to remember not to use that hotkey for the remainder of the stream, and I'll have to do some keyboard repairs. Can I just... there we go. Yeah, I'll have to do some keyboard repairs after the fact. Okay. Oof. Not good. Not good. We'll see if we'll see what happens after this stream. I'm worried about it, but I'm gonna put it out of my mind for now. We should really remap that functionality though, because we need it all the time. So we're gonna go to controls. We're going to say F is now Q. Better. Okay. It'll do. It'll do. I just have to relearn years upon years of muscle memory is all. Which is fine. Okay, here we go. F to pay respects to Q, indeed. You are correct. The Q key will be remembered fondly. Okay, did I do this right? Yeah, I did. Alright, you're gonna just read hand contents and output limit yourselves. That's good, that's good. There we go. And we're going to copy you, and we're going to paste you onto the green wires. And that's just read hand contents. Do not disable. Alright. And then we can start to set this up so that small electric poles, we only really want 10 of those because they're an intermediate. We don't want very many of them. Medium electric poles, let's say... I don't know, 20? 20 on the belts. Fast splitters. Right here. 20. Because they'll be, yeah. Then you will have to be intermediate electronic circuits, and you're going to be less than, let's say, 40 of you. Those are probably going to be slow. We're going to have to make more of those, but that's okay. Yeah. Then you're going to be burner assemblers. Really only want 10 of you on the belt at a time. Even less than that if we could do it. Which we could. Yeah. You become this. And you become this. Which is like this, and like that, and like that. Okay. You should be green. I'm losing it a little bit. Okay, there we go. Hold on. Thinking. There we go. Next output is here. There we go. Input, input, output. Perfect. Input, yep. Get rid of that. And enter this. Okay. Input. You don't actually need to be circuited at all, because what we're going to do is take from behind and put into the side. So it just takes from this one, passes it on to the next one. That's all that does. Okay. Then we just... Oh, very annoyingly, then we just have this problem. Okay. Okay. That's fine. Just go like this. Oh, I hit Q. I hit the Q key. Mistakes were made. Alright, get out of that. Like that. Okay. Good. Now we need to wire up all of that. Wire up all of that. My phone apparently has been very quietly playing a YouTube video in the background this entire time. So that's a thing. These need to be red, though. Which I can do now. Because red is... There we go. Okay. Need stone tablets for those. These could be reversed as well, eh? Okay. You're going to input-output like that. And you're going to be input limited like that. Read hand contents. Read hand contents. There we go. Waiting for source items. That's fine. You should just be reading. Good. Okay. I think that's good. Where is... Oh. There we go. Now as things come through... What is going on here? Hello? My keyboard is definitely still malfunctioning, by the way. There's some weird stuff happening as I walk around. Oh boy. Okay. We are making these. That's good. We need to set the limits for them. Say 50. Let's clear that. Say 50. There we go. Fast splitter 50. Fast loader, 50. No need for... Where are you? Assemble inserters. Give me 100 of those still. Then belts can go over here. 100 of those. These can say 100 of those. Okay, great. Then we want assembly machines. Let's say 50 of them. Let's get some medium electric poles. 50 of them. Okay. And now, as this stuff builds, which we need circuits for and more of those, and those require what? Those require gear wheels, which require iron. Iron's not being put on the belt because the count is off. Okay. That is one thing. Every single time we add something to this to this design, we need to... I pushed Q again. Every time we put something on the design, we need to... the music's popping. We need to then flush the belts and reset the count. It's not terrible. Alright. More circuits, please. There you go. And then wires. There we go. All of those are wired now. Then these just need to be read. And those will be set to enable disable for now until we have something to build there. Alright. So now we need to flush the belts yet again. Oh. Okay. Does it still work? It does, as long as I don't hit a building with it. Okay, because F is also the key to pick up things from belts. Okay, we are flushing the belt. Here we go. That's what this is. We just want to get rid of everything and then reset the memory cell. Oh, dear. The keyboard situation is not great at the moment. I hope I can fix that, otherwise that is a really nice keyboard that I've had for years that'll have to be replaced, and that is really quite unfortunate. Okay, it's fine, it's fine. We're going to set this to enabled disabled while we do this. Just so that we don't get... Okay, good. There we go. And then turn off enable disable. And it's starting to count up again. This is good. And we're starting to manufacture goods again. This is also good. And we will want to increase the speed of all of this, probably. But for now, it is letting iron in, and it is letting copper in at certain speeds. What's going on up here? There we go. Loop is restored. Okay. So now we've got a double loop situation going on here. And they will be able to pass things to each other as well. Now, why aren't you letting iron through? You should be. Something isn't right here. Let's see. Read hand contents. Are we, like, missing a joining wire? Yeah, we are. Okay. Which means we're probably missing a joining wire here as well. Yeah. And here. Yeah. Okay. That's what's going on. So, we'll just go like that, and then we will join them up on the end. And then I'm just going to lazy reset the memory cell this time. It's not a smart way to do this, but it'll probably work. It's basically flooding the system with bad memory, right? So the more memory buffer you have, the more likely that is to... Are you not set to read? You are. Are you... The entire top rows are not connected as well. Okay, so that's a problem. Okay. There you go. And then... There. Now are you all connected? Bottom rows aren't connected either, it looks like. So let's fix that. Yeah. There we go. So now we should have red and green throughout the entire system. Okay. We're going to flush the memory cell lazily one more time. And now it should be working. It's definitely letting a lot more iron and copper into the system now. Yep. Okay, it's working now. More or less. And that copper will all get used eventually. We'll have bad memory in the system until I flush the lines again, but I'll want a smarter way to do that first. Okay, the next thing is stone bricks. And this can make stone tablets. Gonna be stone tablet less than 10, I guess. We don't need many of them, but they're gonna need to go to here, so. Yeah, that's fine. Okay, stone brick time. Let's do it. We are manufacturing, again, which is cool. Oh my god. The keyboard situation is a bad one. Alright, we're waiting on electric poles, all of the red belts, and assemblers. But we have everything else, so that's pretty cool. Electric poles surprises me a little bit. They're missing iron beams. Oh, well, we can get another iron beam assembler going. And where's our iron beam output? Right there? I think. Yeah. There you go. We could increase the iron limits now if we wanted to. We should definitely... oh, I pushed Q. That was a mistake. We should definitely... Oh, boy. It hits E when I hit W now, a little bit. I'm hoping that fixes itself once any water in the system evaporates, but we'll see. It might also, like, cause some corrosion and then the whole thing will break. That'll be bad if that happens, but it's okay. Don't mind me, I'm just rambling. Okay, stone bricks. That's what we're working towards here. Let's grab some ferni. How much steel? How much stone brick do we want? Let's do like, I don't know. Okay. Four smelters. Okay, then we just need in, fuel in, which we could do from, this could be out and fuel in. No, we want to mix the belts. Okay, we'll just do it in a way that makes more sense here. Let's go like this. This is fine. Nope. There we go. There we go. So that'll be for our stone. And we will go like this, and that's stone out. Oh boy. Alright, there we go. It's all good. Hit the wrong button. There we go. We'll just go like that. And then that'll go out onto the far side, and if we can just get fuel onto the inside here. Which is not super hard to do. Come on. Ugh. There we go. Fuel's on the inside. This is a lot harder now. Oh god, stop. Filter fuel to the right. Okay. Actually, we'll just... I guess we could just output far instead. Okay. There we go. There we go. Stone bricks are entering the system. And it'll allow 50 of them in, and then no more. So now, we should see that some stone tablets get made with those stone bricks, as well as some assemblers. Yep. So now assembling machines are getting made in this situation. And you can actually see in real time what we have in the system. We do have some fuel in the system now, which is kind of a problem. What a mess. We are making some of these now. That's great. Okay. Slowly but surely, we are getting what we need here. We aren't going to grab a single medium electric pole because it can only have 4 filters. That's annoying. Interesting. And we are starting to oversaturate the belt now. Which I think part of that is because of the bad memory from before, but definitely part of it is because of other things. So now we should be getting some of these splitters made too. Yeah, look at that. Crafts completed, 5. Cool. And those should make their way over here and get snagged. Yeah, and we've got 3 of them in there already. Sweet! It's working, more or less. Now we should really drain the belts again and fix the memory cell. Also, my keyboard's just occasionally pushing 1 now, which is really quite unfortunate. Boy. Alright. Ah! Why? Oh my god. That's so frustrating. It's not, I mean... Okay. We will. Give me my IQ software. We will disable the 1 key for now. There you go. Alright, should be working. 1 key doesn't do anything. Great. Why does that happen now? E is being hit when I push W. Okay, it's fine. We can't disable that key, really. Okay, it's all starting to pile up now a little bit. I think we have to oh my god. I'm gonna hit R randomly. It is all starting to pile up a little bit. Maybe we have to put the, like, products, the numbers for everything down to, like, 10. Like, 10 for the products we're manufacturing and 20 for the raw materials. It's still flowing. As long as it's flowing, we're fine. If it starts to stack up and like, get backed up, that would be bad. But we are starting to slowly trickle through all of the products that we want to manufacture here. The, good God. Alright. These are slow because of gear wheels. Makes sense that these are all slow. It's basically gear wheels that we're waiting on. And we're waiting on gear wheels because they can't be placed onto the belt, is why. Because the belt is full. So, let's lower these amounts to like 30 of each. So that went from 150 to 90. We just eliminated 60 items on the belt, in theory. And then we still want 40 gear wheels to come through, really. It'll take a while for that to take effect as we use those raw materials. I kind of feel like there are a lot more than that going on. You're not set to read hand content. That'll do it. So it was stone tablets that was a problem, basically. Are all of these the same? No. It's just that one was not set to read hand contents. That's unfortunate. Alright. Just need to make sure all those are set before we have another problem. This should be disabled now. Okay, we're gonna have to drain the, we're gonna have to drain everything off of the, off of the belt. And start this over, I think. Yeah. Okay. Let's disable you. And let's pick everything up. Inventory's full, okay. Still need to pick everything up. We could have an enable disable signal. Like an OR sort of situation where each of these output inserters. No, there's not really a way to do that, is there? We could power switch it. Might be a use for the power switch, which is very rarely used. Good lord. Okay. Alright, let's having a hard time, guys. I am having a hard time. Let's use some of those stone bricks, I guess. I mean, we have to... Please. Please. Allow me to use my computer. Oh my god. It's a problem. It's a problem. Okay. It's starting to be a thing. Then we can put this in here. Except we want a stack of those. We can put those in there, though. And those. Those. Gonna want to upgrade that chest now. Okay. It's not hot swappable because it's the Corsair K95, so very rarely are those hot swappable, unfortunately. Alright. Get these out of my inventory. There we go. Yeah, probably will have to. I mean, it's probably... I'll fix it right after the stream. I just don't want to stop the stream to work on it right now. Like, it'll probably be fine after a little bit of TLC, but... I mean, it could fail. That is a possibility as well. Oh, we have a bunch of science packs in our inventory. Let's go deal with that. Alright. Let's see. There you go. Enjoy all the science packs. No, don't bring them back into the... It's fine. Okay. We're not researching right now. That's fine. We're working on a cool little sushi mall, which I'm very excited about. I wish I had not tried to fix my Q key. the Q key struck back in a big way. The mistakes were made. Yeah, it just needs some rubbing alcohol and a little bit of time and patience, but I don't have that right now. Okay, belt is cleared. Now, we just reset the memory cell. And we can see what was put on the belt. We've got 10 stone tablets, and now we should stop getting more stone tablets. Excellent. Okay. Now we enable this, and we let the stuff through. And we grab what splitters we have made so far in the service of doing one of those guys to allow further throughput in case we need it. What the hell happened here? Okay. I don't know what happened there. Alright, let's see. How we doing here? Things are being made at this point. We've got some medium electric poles in there now. It is picking things up as they come across, as it needs. What do we need still? We need... Oh boy, now there are negative numbers here. That makes sense, that there are negative numbers, actually. Because there's more stuff than we need in there. Okay, that's good. So we're still looking for, reminder, how this works. Positive numbers are things we are still looking for actively. Negative numbers means we have enough. 0 means we have enough, obviously. So, we are looking for 50 more splitters, 48 more undergrounds, red, 47 more red loaders, 46 more assembling machines, and 30 more medium electric poles. So, now we just look at these and see what they need more of, and see why they aren't getting them. These need more iron in order to output more. So, looks like our iron limit might be a little bit low, because our gear manufacturers are missing iron and we need more gears. So we can increase the iron limit. Let's put it back up to 50. Remember that every branch we add adds more limit and more delay before items get to where they need to be. So now that's at 50. Stone brick is filling the entire belt. That's so frustrating. Okay, that's fine. We should be able to... No, I hit Q. It was a mistake. Holy moly. Alright. This needs to be stone brick. Less than 30. There we go. I don't know what went on down here, but it was an absolute disaster. So, stone brick, we have 256 stone bricks in the system now. One way we could fix that is by... Please. Just extracting them from the belt into a chest with a loader, which we haven't made one yet. We have. So there should be 3 sitting over there. Yeah, there we go. It doesn't need to be a red loader. It's a little bit of a waste to use one, but that's fine. Then we need to just read hand contents on the green. Read belt contents pulse. And then a filter inserter. For stone brick. There we go. Now we're taking all that stone brick off of the belt. And we should see that happening. Yep, you can see the number of stone brick is lowering. And we're freeing up all of that space for other things. That is awesome. Then we could just wait until we're down to, 40, something like that, and then we'll disable this. Don't need to run it forever. $50 seems good. There we go. And then we can do this for whatever we need to take off the belt in the future, which is great. Then remove the filter. Let everything through. Okay. So that'll be a way to drain everything off the belt, if we need to. Okay. So now things are being injected a little bit. A little bit at a time. I think we still need more copper. Or more iron, rather. Because these are still not being fed enough. Like, iron is getting through, but only a little bit at a time. So let's increase iron to like 100. Okay. Things are moving a little faster now. Now I think we might need some fast inserters on this side of things in order to actually keep these fed. Because there is some iron, not a lot, not a ton, but there is some iron, so. 100 iron in the system, that should be good. Should be enough. Okay. So now you are missing iron gear wheels, you're missing fast transport belts, which are going to be missing iron gear wheels, you're missing slow splitters, which are missing cylinder engines, which are missing iron gear wheels and iron. Okay. Balancing this is a little bit complicated, huh? But it's cool. It's all of this plus some in this footprint, and much neater. Slower, I think, overall, but neater. I mean, it shouldn't be that much slower. We still have 4 gear wheel assemblers. We've only got 1 belt assembler. That could be part of it. I mean, we could add another one, but realistically we need another single cylinder assembler before that is worth it. And this is... We might just need more gear wheels or more single cylinder engines in the system at this point. Because that's reading 20 at all times, basically. Slowly creeping up. We'll see where that balances out. if it gets to 40, that means that 1 is still keeping up with demand, or with the, or at least it's keeping up with, yeah, it's keeping up with demand. It's keeping up with the flow of the flow of those through the system, at least. Copper cables. Okay. Steel would be the next thing to bring to this party. Because with steel we can start to make all sorts of other things. Interesting. Output is full now most of the time. So, automation cores. Where are those getting made? Way down here. They need more copper. They just need more input. Okay, so we just need... Are we out of electricity? No. Not quite. So that just needs more input. We need fast inserters for those. So let's go grab some... Dear God. It's so frustrating. Let's go grab some steel. Oh, we don't have it up here anymore. That's fine. Let's get some steel smelting going on. Production. Sure. Okay, let's take a look at this. 6 coke per 16 seconds. And steel requires 3 coke per 16 seconds, so it's 1 to 2. Okay. You will output there. Input there. You will input there. Output there. There we go. You need wood and coal, so let's do that. And a little bit of fuel. And then something like this. And then we just need coal. How hard would it be to... There's stone right here and rocks right here, which means there's stone and rocks. There's coal right here, and there's stone right here, which means we could get a greenhouse together and make some wood right here, and that would make coal. There's also iron ore right here, which we could then smelt into steel. So that's a thing that we could do. We'll think about that. Oh boy. This is gonna be real hard to edit around all of the glitches. It's fine. We could disable E and move the inventory button to like I instead. Get rid of anything that reads E at this point. Okay. Now, we do need to be able to open the inventory, obviously, so that's going to be I, and that's going to be enter. There. T is also getting pushed occasionally. That's crazy. That's like 3 keys separated. That's alright. Okay. We'll fix it right after the stream. Alright, getting some steel together, just some ad hoc steel in order to get myself some more fast inserters. Which is... There we go. Put those on the hotbar. A little bit better now. Now then, you're missing copper. Why isn't copper being let in? Copper less than 30. Copper is definitely less than 30. Okay. Fine, that's fine. I'm gonna lose it. Okay. Alright, let's increase copper supply now. Oh my god, and now that's rotated. Why? Insanity. Alright, double it. 60. Okay. You might need a fast one. F. Okay, there we go. Your factories are doing their thing, a little bit at a time. How we doing over here? Slowly but surely, we are actually picking some stuff up. Okay. We're injecting a little bit of copper and a little bit of iron whenever we need it. Now, what am I waiting on here? I'm waiting on all the red still. So let's look at red. You're waiting on red belt. You're waiting on red belt. You're waiting on electronic circuits, which are waiting on copper cable. Copper cable is just waiting on more copper to be injected, basically. And you're not picking up assemblers because you're waiting on the reds instead. Okay. So that is an irritating thing about this, for sure, is that it picks what it wants and then it doesn't update that until it has picked up all of them. And it can't have more than 4. Why can't it have more than 4? That's annoying. That's really annoying. There's a couple of ways we could do... there's a couple of things we could do about that. We could, first of all, music could do its thing. That would be nice. Alright. We could have another filter inserter on a separate constant combinator, and we could split it out just 4 at a time. That's a thing we could do. It would be a little bit annoying. Constant combinator, that just reads from the chest and outputs onto the line. We could split that out to like a red line instead of a green line on the output. Feed that back into the inserter. And then, yeah. That's probably the way to do it. How many items do we have? 12, basically. 11. So we need to make some more filter inserters. 2 more. And we need to stop hitting Q. Alright, there we go. Okay. Alright, here we go. So, then we need to make some more constant combinators. And we need to output just 4 things on each constant combinator. So, then, that gets fed into the input line, like that, and into let me see here. Stop. Alright, so you should be outputting negatives of that. Then those should combine with the constant combinator. To feed. Okay. Then they shouldn't all be linked anymore. Let's get that out of the way. Okay, so we've got 3 constant combinators. Let's assign them like so. And then that's going to be green from the combinator to the inserter. And you're going to be on set filter. And you're too far away. Try it again. Set filter. Red from the output to the input. Okay, that seems to be working. So red reads what's in the box. And, hello? Oh, it's not on a, obviously. Yeah, red reads what's in the box. Green tells it how many of an item it should pick up. Set filters. So you pick up from there, perfect. You drop off R, pick up near, and you drop pick up there. Okay. Disabled by control behavior. Set filters. There. Now we can handle 3 items being picked up simultaneously without having to wait. So that's pretty cool, I guess. "43 assembly machines." What's that about? Okay. Any of these others badly managed? Yes, apparently. How did I do that? Could have sworn. It's alright. Doesn't really make a huge difference, because these weren't keeping up anyway. That's set correctly. That's set correctly. That's set correctly. Okay. Great. Now the whole thing is indeed working, which is cool. Now, this is not as good as it gets, right? the idea is that once we have logistics robots that can take from chests and bring things to us, this becomes a provider chest, and those robots can just bring us stuff from this chest, and this is just our buffer. For now, it's pretty cool how it is, though. And we do have some undergrounds and stuff going on. That's pretty cool. Where's our fast belts being made? They are being made right here, so they should be picked up first. Oh, we already have more than 100 of them. Sweet! Look at that. That's really cool. Alright. And that controls our outputs perfectly, so we can just put stuff in this chest when we want to, when we have an overflow of it. It's great. One extra somehow. Interesting. That's fine. Alright. That is great. Okay, now, we can also make lamps here if we just bring glass in. That's all we would have to do to bring... to get lamps going. So we will do that. Pretty simple, really. Glass comes right here. Okay. Then this is going to be glass less than 50 instead. And now there's glass on the belt. But this is actually going to go to here. Because we have one of those. And then this is also going to go like this. And that's going to be glass. Nope. Glass less than 30. And that's going to be stone bricks less than 30. And I just realized that I'm not talking into the microphone at all, so you guys probably couldn't hear me super well there. My apologies. Wrong. Hello? There we go. There we go. Okay, so now we've got stone bricks and glass, and now we can very easily just set up lamps like this. You're a lamp assembler, and you're a lamp less than 20 condition. There you go, lamps will be made. We should probably have a couple more of these guys. Let's see what the... There you go. Hey, easy enough. Now lamps are on the belt. This is great. Sushi belts are great. This is the first time I've ever done this, like, for myself. I've seen it done a bunch of times, but I've always kind of wanted to, but never really, I don't know. It's never been a high priority, I guess. Alright. Now, all we're waiting on is the red belts of different varieties, which are pretty much all waiting on just the normal red belts, which are at saturation. That's interesting. So it's just taking that long for them to route all the way around, I guess? I just realized that how we were doing it, things that settled on this loop would never actually be seen by the other loop. Because the splitter will always switch all the items. So we were switching and then switching again, meaning that they would never actually cross loops. So now, these items will be seen by all of these, and then all of these. Okay, great. That's how it should be. We've made a figure 8. It shouldn't have been that hard, but it was. Also, our count is off a little bit again, but that's okay. It's okay for now, anyway. Oh, we need to actually pull lamps off of the belt. 50 of them. There we go. So now whenever this guy encounters a lamp, it will insert it into this chest. Yeah, pretty cool. Okay. We've been working on this probably for too long at this point. I'm fascinated by it. And I kind of want to, I kind of want to keep going, but you're just waiting on red belts. That's all you're waiting on is red belts. And red belts say they're full. Is it possible? Are these set to read hand contents? So the count is off entirely again, is what that means. Okay. Okay, that's fine. We can fix that. So, here's how we fix that. We just drain the... I can't get into my inventory anymore. We just create a buffer, like 3 iron chests worth probably. So it'll be splitter, loader, chest, loader, loader, chest, loader, loader, chest. Okay, sure. It'll be at yellow belt speed, but that's okay. Okay, so we can drain everything off the belt like this. And then we need to actually disable the input. There you go. Okay, there we go. And this will go here. And we will set the output priority. There we go. Now we're draining everything off the belts. And looks like it's gonna do fine. We can just set this to output priority for a minute, and then it'll all drain out. And then my plan is to insert this stuff back onto the belt and read the contents. And then we know exactly how much of everything we have. Which is smart. And we're going to go the extra mile and clear the memory cell until all of this stops moving. Okay. Memory cell is clear. There is nothing in the system. Then, we just have to connect our output, and it can all fit in one iron chest for now, which is awesome. So I could have done this in a smarter way, which I will do now. And we will just be smart. Load in, load out is how it's going to look, but for now we're going to go like this. And please, there you go. Alright. So everything goes into that iron chest, and then we output it all onto the belt while reading the belt contents. And then whenever we want to drain the belt, we can super easily do so. Which we really shouldn't have to do very often, but, you know, it's good to have a way to do it. Let's go here. And then this is where we read onto the belt, yes. So go here. And read belt contents. Do not enable disable. And then we use a splitter here and here. And output priority right to get it back on the belt. And away we go. Okay. Priority left. Ah, damn it. Now it's gonna duplicate everything. It's fine. It's fine. We can easily fix this. Just set this to enable disable and priority left again. So now everything's coming off the belt again. I forgot to make sure this was sending things past the I'm actually going to be even smarter here. And we're going to move this by 1. And let's just put a bunch of stuff in here. What have I done? Okay. Nope. Try again. There we go. There you go. Get out of there. Okay. This is fine. Let's just do a belt there. Why am I... There we go. Alright, belt followed by loader. Loader, loader. There we go. And then we can now this can take off the belt. And that'll enable us to see how bad it is. Basically, is the idea. Okay. So turn that on. We didn't need to turn that on yet, but that's okay. Let's get this. Turn off the priority there. Once it's drained out, we will allow things to run for a moment and then turn back on the priorities to actually drain the belt and see how far off we were. Which is as easy as switching that, and switching that. Oh, and switching that. Okay. Let's say red signal equals 1. And let's say enable disable on green signal equals 1. And then we can just choose when we want to change the belt. I do wish that these could be wired in order to, you know, continue that, but that's okay. Okay, so now let's clear out the buffer like this and turn that on. Now that should clear out the buffer chest entirely. And that is as if the buffer didn't exist. How far off are we? Very, very, very far off. That is how far off we are. Okay. So now, we just need to disable that and switch this, and the belt is drained. And enable this. Don't know why the music just decides it doesn't want to. How far off are we now? Still very, very far off. Okay. So now we will disable the memory switch, let everything run, get everything out of the system, and it should literally be everything out of the system because those should not affect the memory at all. Or there is no memory right now, obviously. Okay, everything's turned off. Here we go. Memory cell re-engaged. Then, turn off the output priority here. Reverse the output priority there. Disable that belt. And enable this belt. And then all of that will be read back onto the belt, and the memory cell should engage correctly. Excellent. Excellent. And then anything that I want to put on the belt, I can do so. Like that, or those, for instance. Those. Okay. Yeah, this is great. We can put... So now we have an actual accurate count of everything on the belt, which is amazing. Things are just filtering through and getting made slowly but surely. And now it's time to enable or disable this to allow the other things through, which is just iron, basically. Which is good because it feeds the gears. And we're almost overloading our belt capacity with that, but not quite. Okay. And then we are still waiting on red stuff, which is waiting on yellow stuff, which is waiting on iron stuff. Or waiting for space and the destination to output. Okay. That makes sense. It's almost at its capacity here. We could turn down some capacities if we wanted to. Like, we could say we only want... Well, it's at capacity because of glass and stone, probably. Which are probably not going to be drained until we use some, because nothing but these are using glass and we already have enough of them. Okay, that's fine. Now you're waiting on single cylinders, which are waiting to output. Makes sense. That is one bad thing about this design, I suppose. Is that if the belts fill up, it kind of grinds to a halt a little bit. We could drain the stone and glass off of the belt if we wanted to. And then just slowly add it back on. Realistically, I think the best thing to do is to lower the amounts it's stone and glass, and probably lower the amount of iron to like 60. To be in line with copper. There you go. That should give a little bit of extra space, like 40 spaces throughout the entire system. This is fascinating to watch, though. It is easy to expand. It has that going for it. Okay. Let's just get glass in, I guess. Which is easy enough to do. We just disable that, enable this, and filter this for glass to the left. That should have lowered our glass supply by a bunch. It's good. And then we filter this to stone. enable that. Drain off like 50 or 60 stone. Now there's some space on the belts again. And disable and clear the filter. Okay. That's better. More like what we expect. Why are there 30 of you? That makes sense, I guess. Let's say, woo, no. Let's drop all of these to 10. 10 of each finished component is allowed to be on the belt instead of 20. 40. Don't know why you're so high. It's fine. 40 of you makes some sense. 10 of you is good. 40 of you is good. 10 of you is good. 10 of you is good. Let's go with... Yeah, we'll leave you at 20. That's fine. 40 of you is good. 20 of you is fine. 20 of you is fine. Okay, good. Probably good. Only 10 of those. Only 10 of those. 40 of those. 20 of those. Good. Good, good, good. 10 of you. Alright, so now it's all about... Oh, disabled by control behavior, really? Oh, we're not missing splitters anymore. Awesome. Okay. So it's all about the undergrounds and the loaders at this point. You're just waiting on output is full. Okay. Undergrounds are waiting on them. It says the output is full. I'm just scanning the center area here, trying to figure out exactly what we want to do, or trying to figure out where those are. Is there one of you not set to read hand contents? I just don't see them. Maybe they're very hard to see, but I don't see any of those red belts on the belt. Okay, let's double this. You reading hand contents? You are. So looking at the red belt number is at 25 currently. Now 26. It's not... This isn't being... Because of course it isn't. That makes perfect sense. Okay. Okay. Which one was it that needed to do that? This one? Right. Okay. It's getting constant. Yikes. So those aren't reading the contents. Is why those counts are off. how do we fix that? Because this will have a bunch of junk data on the red line. Because it's outputting the red line. We could... Okay. Here's what we do. We... red line here, take everything, multiply it by -1, output everything. Okay? Then, we add those together with... No, that won't work. Because each of these has a constant combinator. Okay, here's what we do. I've got it. Okay, here we go. We need 1, 2, 3. And we need the green line, and we need the green line from each of these, minus the red line from the constant combinator. And that should allow us to but it's gonna be okay, because we need that minus, because we need to read the hand contents and put them into the memory cell, is why I'm doing all of this. I know this is probably impossibly hard to follow because I'm not explaining it well, but basically I need that green line. But I need to subtract the constant combinator from each. So, how are we going to do that? We're going to have to use 2 arithmetic combinators for each one. So it'll be red from U and green from U. Nope. Try again. And green from U. No. Just one. Here we go. Shouldn't the filter inserter just behave the same as the inserters taking stuff off the belt to put into the machine? Super. Yes, they should. The problem is we're using both channels, both the red channel and the green channel, to set the filters for the filter inserters. I could do this in a million different ways that are probably easier, but this will work. I just need to subtract these and then put them on their own network. Okay, alright, here we go. Here's what we do. So, it's going to be the outputs of all of these into the inputs of this one. Rotate it. Then it'll be subtracted each times 1 output each. That's fair. You can see, the entire stream today has been spent dealing with circuits. I do enjoy it. But it's difficult. So, we're going to multiply each by -1. Output each. Here we go. Okay. Then, I hope I didn't mess that up? No, I didn't. Okay. So now we've got a negative version of every one of our requesters. And then we put the red... Did I do it wrong? I did it wrong. Okay. Because this needs to be red and those need to be green. Which will have their hand contents. It's setting filters. Okay, okay. Alright, 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 alright. There's a smarter way to do this. There's got to be a smarter way to do this. So, we're going to go back to the drawing board on that. And we're going to put the output over here instead. So that we can see more than anything. Then filter inserters, here, here, here. Pick up from long. Okay. I think we just accept that it's going to be a little bit slow, and we use no. I'm going to figure this out. I'm going to figure out a way to do it the way I want to do it. Just because it'll be interesting to figure this out for me. Maybe not totally for you, but for me it'll be interesting. All right, here we go. We need inserters. I want 100 of them. Did that not save? It did. Okay, good. We want lights. 50 of them. Medium electric poles. 50 of them. And assemblers. 50 of them. So that's how many we want of those. Now, that's going to go on the green wire. That's going to set the filters for that. Then we're going to have an arithmetic combinator. Eyes. There we go. Found it. Nothing to worry about. It's going to go here. On the green in should be fine. Green out also should be fine. And it is going to say, for each item in the chest, output each item, but negative. And then it'll subtract it. So, then, let's just dump all of our stuff in here. Electric poles. Seems like everything. Can I just pick that up? Excellent. Okay. Okay. We want 100 of those. We want 50 of those. Sure, 50 and 50 of those. Why not? Loaders, that's fine. Do we have splitters? We do. Burner inserters. Don't know how those got in there. Don't want them in there, though. That's for sure. Undergrounds we'll take. This is fine. Okay. Oh, and these. Okay. So now it is inputting from the chest and outputting, but we need one of those. Is that right? Yeah, that's right. Okay. Okay. So that is one. It shouldn't be on the same color, though, should it? Because we want just the one to do all of them. So let's disconnect you from that and connect you to that instead. You still... Yeah, you're still adding. Okay, good. Alright, so then it's going to be red from the constant combinator to the filter inserter. Green from the arithmetic combinator to the filter inserter. Okay. And now none of these should have... Only one of them has a filter, and it is inserters, and once I put those in, no filters. Okay, it's turned off. Here we go. We are going to have to drain this belt again, which is frustrating. Hey, George! Welcome back, bud. Yeah, this is a... this is an approach. I can't claim full credit. People have been doing sushi belt mauls forever, but this is my take on it, and it's not amazing yet. We're working on it. We're getting there, though. Okay, so now we have red and green. Is that a problem? Wouldn't be a problem if we used an arithmetic combinator for each. There we go. Okay. Alright. So it's gonna be red. There we go. And what is that? That's green from the chest to the arithmetic. There we go. Okay. We're getting there. Green in, red out. Now we have a green channel from these filter inserters that should have nothing on it. And we're going to see if that's true right now. Nothing on it. Okay. So then that is the hand contents of the filter inserters, because we can just read hand contents in pulse mode. Okay. Here we go. We're picking up steam now. It's happening. Now, what does it need to be on? It needs to be on the green wire, which is perfect. So now we just have to attach those green wires, which I'm going to need to make more of. Amazing that after all this, we're still handcrafting things, eh? And connect them up to that. And now when we pick things up off the belt, we should be counting what we pick up off the belt. Yeah. Okay. Great. Now, we need to drain the belt again, turn the system back on, and see if this is actually working. Because at least one of you should be outputting things, right? Yeah. I just haven't set the limits for all these yet. 50 of those, 50 of those, 100 of those, and 50 splitters. There we go. You should be... Really, we have all of that? No. You should be... Oh, set filters. There we go. Thought I was losing it there for a second. Then we should be seeing things get subtracted. That looks like it's getting added. Okay. Those were definitely getting added to the count, and I think I kind of know why, but not really. It's because we need to output them here instead, because that is something like that. I did this for a reason. I'm sure I did. Why is the red to the red and the green to the green here? Is there a reason for that? I mean, the red doesn't do anything, except it might be doubling. Why is the green there? Think. I don't remember, so I'm getting rid of it. Okay. Clean up a little bit. Okay, let's drain the belt and see what's going on. My eyes are glazing over. Okay. Belt is being drained. Disabling the input belt. Satisfying to see everything drain out of this signal loop for sure. Drink some water. Chat, you too. Hydrate. It's important. Okay. Belt is drained. We are significantly off our count. Which makes sense. Disable the memory cell. Things output the last of what they have. And then we enable the memory cell. It should be at 0. Okay. It's at 0. That's disabled. That's perfect. Now we output all that stuff back onto the belt after we disable the priorities. There we go. Disable that belt. We enable that belt. All that stuff flows back onto the belt, loading up the memory cell, and we have stuff on the belt again. We'll just let it come on in. And I'd really like to see what happens when one of those takes something off of the belt. Oh, hey, it worked. I saw it work. Okay. You might not have seen it, but the red splitter went down from 2 to 1 when it grabbed the splitter. And it just went down to 0. Oh, yes. And that, okay, it is working. It is working. Okay, let all the stuff in. Why is glass so big here? Should be 30, but instead we have 140 of it. Curious. Oh, that does make some sense. Okay. Okay, okay. So that's our mall for the time being. We'll check back on it in a minute. I really want to... I can't help myself, chat. I need to drain the glass out of the belt. There's no reason to do so. I don't have to do it. Someone stop me. Save me from myself. We need to move on. We've been working on this forever, and all it does is replace the thing that we already have. Ridiculous. Okay, let's get those mining drills on here as well. Should be easy enough to do. It's just... I'm going to redundancy that and that so that we can output from this one to that one there, and then this needs to be an input. There we go. And you are electric mining drills. We're learning a little bit at a time here. Just want 10 of them. Okay. And we're going to add that to one of our existing filters over here. We'll add it here. I know it won't always filter that, but because those are stockpiled much easier, it will get added to the filter. Electric mining drill, we want 50 of them. And see, filter got updated immediately. And if we look at this, there is one in the system. Might take a while to get all the way around, but there is one in the system. I love how it slowly injects iron over time. That's a cool, that's cool. Okay, it just picked it up, and another 2 got added already. Lovely. Where is it? There it is. Electric mining drills. Okay. I think that's fully functional now. We could make repair packs. I don't see a stone! No! Heck. I mean, alright. We can... we can get stone in here somehow, I'm sure. Why is... we can't... not right now. Not right now. Why are they made with stone? That's dumb. Doesn't make any sense. Ah, this is lovely. This is great. Okay. And that is everything from the mall in a single chest off of the sushi belt. I love it. It's really cool. It's a lot more confusing to look at, that's for sure. Like, you compare this to this thing over here, and this almost starts to make a little bit of sense, huh? Yeah, wow. Alright. Okay, let's move on now that we've done, oh, so very much. Let's check our pollution cloud. It shouldn't really be that much. In fact, it's less than it was before because we haven't been researching it all. So that's not a problem. What is our next step here? Our next step is science. Either military or chemical is the next step. We do also want like modular armor at some point. Railways is going to be necessary. Let's look at plastics, goes to advanced, goes to mining productivity, that's handy. Chemical goes to advanced oil processing, which Didn't I have a bunch of science packs earlier? I did, but I think I got rid of them. Yeah, I did. I did get rid of them. Good shout, though. We're also going to do one of these guys. Can I... Thank you. Input priority right. Get all this stone brick out of my inventory. Love to see that. We can buffer chest here as well. I'm getting used to the new controls. It almost seems like it might be working now, because I'm not getting weird inputs anymore. We're gonna try it and just see if we maybe got lucky. Alright. Clear those. Yeah, I'm thinking that's what happened. What a stupid... What a dumb problem to have. Is there a receptive default button here somewhere? Probably not. Alright. E. E. Q? Okay. Did I not just tell you to... I did. Red arrow thing at the top right. Thank you. Good spot. Okay. Well, the Q key isn't working still. But E is now working. And 1 is not working either. Oh, it's sometimes working. Okay. Oh, and now Q is working. Yes! Okay. Whew. We're back in business, boys and girls. We're back in business. You may have missed the fun, Super and George, before, but basically, weeks ago, I spilled something sticky on my keyboard. And the Q key on my keyboard, which is used for a lot of things, but in Factorio it's used to pick things up, it's an eyedropper tool, got sticky and got like progressively more sticky over time to the point where it was just kind of unusable today during the stream. So in my infinite wisdom, I decided to try and fix that while live streaming. And it broke entirely, and the entire computer started acting like it was possessed, and all the keys were being pressed at once. But now it's working and it's not sticky. So what I learned from this is that I will not learn my lesson from this. Ever. I refuse to learn a lesson from this. It was exactly the correct thing to do. And that is that, I guess. Medpack. What do we need for this? We need fish for medpacks. Okay. Are there fishies in the water? There are. Okay. I think I want to set up a little fish farm here. And yes, that is a thing that you can do in Factorio. We're gonna double up on our fishing capabilities here. An inserter can grab from the water, which is kind of cool. Just... Oh, now I'm used to the weird controls. Output, chest, long. Okay, there we go. And let's just go here, and there, and there, and a light. Okay, now when fish come up, they will get plucked from the water by these inserters and placed on this belt and into this chest. And then we can use them in the way that you use fish. That is to say, we can eat them to heal ourselves, or we can craft them into med packs. Okay. Mall is done. Mall is working. I'm considering it a win. There's still so much glass. You know what we can do to fix the glass problem? Take all the lamps. And then we'll start to use the glass, and we won't let any more glass in. See? Thinking. I'm thinking. And as the glass passes the... Yep, it is getting taken out of the system. Slowly. Yep, it is getting taken out of the system, though. Gonna replace this with a vast inserter. I don't think it's necessary. I'm so used to the weird controls that I mapped to fix the controls that were broken that I keep pushing the wrong buttons now. Okay, great. Now glass is getting taken out of the system, slowly. Isn't that a cool... It's cool, isn't it? I think it's cool. I think it's a neat... yeah, I just think it's neat. I think it's really... I think it's really neat. And now we have basically infinite numbers of the most important building in the game. So that's cool as well. We can place these everywhere. And they are the most important building in the game. Alright. You know what I want? I want to beeline robots. That's what I want. Let's look at logistics robots. Let's look at them, but less capitals. Alright, logistics robots. We need chem science. We need a bunch of technologies in order to do this. So, let's research oil processing. Followed by sulfur processing. Followed by silicon processing. That'll give us solar energy as well. Pretty cool. Let's see, then... Sulfur is already on the table. Plastics. Advanced electronics. There we go. That's the plan. And for this, we are going to need advanced circuits, which are going to need electronic circuits and copper cables and electronic components, which are going to need plastic, silicon, and glass. Plastic is going to require coal and petroleum. Petroleum is going to require oil processing. So we will start thinking about oil next. We do have oil on this seed, which is an amazing thing to have right here. We have 1.7 million oil just a hop, skip, and a jump from where we're currently standing, which is insane. That never happens, really. So this should go pretty quickly now that we've upgraded our labs to 2 layers, but we could upgrade them to 3 layers if we wanted. Is there any reason not to? No. I can't think of a reason not to. Then we'll have 15 labs going consistently. Pretty sweet. I have no idea what the video for this stream is going to look like, by the way. Like... Hello? Thank you. I mean, I had a plan. Well, I mean, not really a plan. I had an idea last stream of what we were going to get up to, but no idea this stream. Okay, where are these? These are here and here. Okay. There we go. Let's remove that. Now we've got 15 laboratories. Oh, look, oh boy. Alright. Let's get the basic tech cards put away into one of you, and automation cores put in one of you and just trying to get all the stuff out of our inventory now, which is difficult to do. Oh, how's our landfill factory doing? Time to check up on that. We do have 3 stacks. I'm gonna actually remove the limit on that and just always be making landfill. It's one of those things that we will need more of. Yeah, I know I should get even distribution. I meant to get it before I even started the run, and then I thought I didn't need it. And I did, but I mean, I don't know. Sunk cost fallacy, right? It's too late now. Alright. Oil processing is going to get going pretty quick here. We need to think about... We do have walls, right? Yeah, it is super essential. Stone walls require stone brick times 5, and it makes 1. So we need a ton of stone to make that a thing. But we do want to think about... oh, gun turrets. Let's add gun turrets to them all. You're right, you're right. I could add it. Probably should add it. Gun turrets. Dude, I love this mall design. Now that it's working, like, I know we spent kind of an ungodly amount of time doing it, but now that it's working, we can just... It's infinitely expandable, because we can just add another ring whenever we want. It's so cool. Let's add gun turrets to one of these filters. We'll do it on... Oh, I didn't even filter you. Okay. That was smart of me. Okay, we'll do 100 of you, 50 of you. It's useful to have both red and yellow belts, at least at this stage of the game, in my opinion. Mostly red and yellow underground belts, though. Okay. And you will also get gun turrets added to your filter. And we want, sure, 50 of them. Are you not setting filters? You are not. There we go. Now you're setting filters. Make sure they're all set to set filters. Great. Good stuff. Okay. Okay, oil processing's done. We could get oil pump jacks out of them all right away. Easy enough to do. I think we have everything we need for it. Steel. Damn it. This close. This close. We were this close. Okay, so now we need to think about an actual steel setup. So that's the next thing to do, I guess. So, steel requires wood and coal, which turn into coke. Let's just look at it here. It requires iron plate and coke. Coke requires wood and coal. So we need wood, coal, and iron ore into a smelting array. Or iron plate, wood, and coal alternatively. And this whole thing is going to have to change because we're running out of iron down here, and all sorts of stuff is happening. Like in the background while we've been just fiddling around. The game is moving on without us a little bit. So we do need to think ahead here a little bit. We're going to need to get wood and coal. Wood is pretty easy to do. The question I'm asking myself silently in the back of my mind here is, do we want to start to rebuild and redesign the smelting arrays now, or later? And also, the second question I'm asking myself is trains, which is kind of a statement more than a question. We need to think about how we're going to integrate trains into our base. Usually I do a very, very train-heavy base once I get things actually working. Maybe we do some sort of bizarre combination of trains and sushi. And that is the base for this run, is trains and sushi. we bring the resources in on train, all of the raw resources that are needed for each individual build. and then we build sushi for every build. No, it would be obnoxious. It works really well for something like a mall that has just, dozens of little intermediate components that you need to think about, and, sushi works really, really good for something like this. But for something that you need in huge quantities, it would drive us insane sitting around waiting for a belt to spin around like this when we really don't need to do that. So, probably not. But we will do some sort of train something or other. Maybe we start setting that up today. Which would mean departing from this and going railway train signals instead. Yeah. I think this is the way we go. We'll come back to robots. For now, we will get trains going, because if we can get trains, boy, can I hold on? This does take steel. Either way, we're making a steel build. Let's make a steel build. I need stone for my steel build, and we're going to. What do we want to target here? It makes 5 per 16. Why does it make 5 per 16? Okay. Steel. 5 per 16. Do we want a steel a second? Is that ambitious for this early in the game? That's only 3 furnaces. No, we'll do 2 steel a second. 5 per 16. That's 8 would be 5 per 2. Sure, 8 steel furnaces. That's our plan. We're going to put it right here. And we are going to think this through. So it needs wood. No, it needs coke and iron and fuel. And remember that we have some weird stuff we can do with inserters now. Like we can pick up at angles, and we can deposit at angles, and we can do all sorts of stuff. Let's get this meteorite out of my face. So let's think of the most. I'm just trying to make it the most compact we can, obviously. So if that's an input belt, that would be coke and iron. Then we would need an output belt. And we could make it really cursed and do some belt weaving immediately. No, we couldn't. You still need space for the inserters, you dummy. Alright. Oh, and this isn't even going to work. Okay, never mind. This is fine. We'll just... So this is input, this is output. In, out, in, etc. In, out, in, out, in, out. There we go. And then we do this here. And this is out, in. But for the out, we drop long. And drop long. There we go. Or, nope. That was wrong. Hold on. Drop near. Pick up long. There we go. Okay. So that's our 8. So input output. This needs coal. This needs coke on this side. Iron plate on this side. We can branch iron over here if we want to. That's not really a problem. And then we can make coke. Now to feed 8 of these, it's 1 coke. You can see it right over here. It's 1 coke machine to 2. To 2. So 1 to 2, 1 to 2, 1 to 2, 1 to 2. So we need 4. And they need wood and coal, which can act as fuel and ingredients. So we will do like something like this, and this is going to make Coke, and then we just need input, which can be here, I think. So wood will come down on this side, coal will come up on this side, or vice versa, and then output. And then this is iron. Beautiful. Let it never be said that we didn't do something today. Put that there. Let's get some lights going on here. Okay. So wood and coal. Coal, very easy. How much wood and coal? 6 per 6. We want 8 times this recipe, so we're going to be taking 24, so 1.5 per second. Did I do that right? 8 of these. So 8 times 3 is 24. Divided by 16, it's 3 over 2. Yeah, 1.5 per second. Okay. These make... We know this will make 1.5 per second with 4, because it'll make 24 per 16. Yeah, perfect. And that means we need 15, not 16? No, it consumes 15 iron plate. It outputs 5 steel plate. Yeah, I mean the craft time is 16 seconds. Okay, and then coal and wood, we need each of them 1.5 per second. That's really easy math. Thanks, mod author. We're just going to add a little dedicated coal thing here. 3 is enough, actually. So we're going to do something a little weird there. There we go. Oh, hello. Hold on. Get around there. There we go. Okay. Now this will go up here. And in here... It's gonna get weird. There we go. My Q key working makes me so happy. We are low on power. We're going to need to fix that as well. Then wood will go on this side. Now, 1.5 per second. Reminder, each of these makes 3 per 2 seconds. Because they make 40 per... Right? They make 40 per 60. So they make 2 per 3. We need 1.5. So we need 3. Yeah. 3 of them. We need 3 of them. 3 greenhouses. Coming up. Then we're going to need a crusher to crush the stuff into the other stuff and do the things with the stuff. You follow. You know what I'm saying. The stuff. Alright. We need 3 of them. And they need to go there. Can I get over there? Yes, I can. And we will put one of those there. There we go. Wood will come in here. There's some seriously fine spaghetti going on in this base, I will tell you. We'll put the 4 of these things down here, I guess. Okay, our trees are starting to die a little bit. We are going to need to focus on defenses soon. Like, really soon, honestly. We want them back at this level. And the reason we want them back this far is so that we have room to output and to input. Because you can input and output. So this is going to go here, here, then like this, and then like this. Then this is gonna just... We'll work it out, okay? Did I say we need 4? Or did we need 3? Losing my mind. The numbers. What do they mean, Mason? Okay. 40 per 60. 4 per 6. 2 per 3. 3 fingers. 2 per 3 times 3 is 2 per second. Yeah, we only need 3. Then we need something like this. There we go. Sand goes in there. Crusher, where did you go? There you are. Crusher. Why do I keep losing that? Okay. Crusher. Stone goes in here. Now, 1 stone makes 2 sand. We need 10 sand times 3, so 30, times 60. So we need 1 sand every half second. So we only need 1 stone every quarter second, which means that one mining drill facing directly into this crusher is enough to feed all of these. That is what that means. Somewhat surprisingly and hilariously. Alright. There we go. Now we will... Oh, this is just funny. Now, where does it need to go? It needs to go here. So we'll go here, but here. And here goes there. And this goes up, and this goes up and up. At this low of throughput, there's no real reason to do all of this, but I mean, by that I mean 1 belt could very easily handle this on 1/2 of it, but I'll take it, you know? Okay, now we need water, and then we're ready to go. Okay, now we should see all of these start to feed. This is good. And then we need underground. Let's make a few of them. Oh, didn't need that. Get rid of that. Underground, we have 1. I don't really want to... It's almost like it was meant to be. It's ridiculous. I don't think we're going to do that. Feeding it off of the boilers is a bad plan, but it is funny. That's for sure. We're gonna do it. I mean, we're gonna have to upgrade this, right? Because we're running out of electricity. Yeah, time to add 2 more of these anyway. And then we could put these on the... Oh, except like this instead. And with a thing. A thing being a pipe. And like this being also a pipe, I guess. I don't know, guys. Okay, there we go. Let's get that underground. One more of those, please. They go super long in Krastorio. Alright. Then this just goes here, and we make a bunch of these. And make sure that we have... et voila! I present to you a Coke. Eventually, once these actually do their thing. But you will see that this is plenty of mining capability to feed all of these, which is just hysterical. That's really funny. I enjoy this more than I should. Okay, now the thing is, Coke could be fuel. Shouldn't be fuel. It would be better if this was fuel. So, that's easy to do, because that's going to be Coke, and iron. Oh, wait. No, the Coke has to be fuel, which means our ratios are wrong. Oh no. We need an extra Coke oven for fuel. That's not good. How to do that? I guess we put one on this side, and we belt this to here, and that'll still be all the ingredients needed, and then we output near there. Okay. Okay, so that's Coke, and enough Coke for both fuel and the ingredients we need, I think. Now we just need iron, and we have steel. Now iron is a bit of a thing. I mean, I am going to just spaghetti it for now. But it is a bit of a thing. We need it here. So we'll bring it across like this. And like this. There you go. And we'll pick up some, which is really easy to do. Love that. And we will have steel. There we go. So now we just need to expand iron, and all of a sudden we have steel smelting, which is great. We're gonna chest this for now. Okay. We need way more iron to support, like, I didn't calculate for the amount of iron we would need, but it's ratio built for the wood and the coal and the stone. So the iron we would need basically we would need 8 iron per second to support that fully, which we can't do with our current mining situation at all. And I mean, we could improve our iron mining situation, certainly. Music, could you please? I would love it so much if you would just autoplay like you're supposed to. That would make me the happiest. Alright, let's get some more. There you go. And we're just going to go like this, I think. And each one will have one of those and one of those, and that's just going to be a little modular smelting thing that we do. There we go. Just added a bunch more iron smelting, which is good because we're basically out of ore. When the music is on, it does great, and we will be, there will be a surplus of stone. That makes sense. Not stone, wood. But that does mean that actually we do need four miners for coal rather than 3, because we're using the coal for... It's nitpicky. It's not really a thing, but we are using the coal for fuel. You can see it's being burnt as fuel for the coke, which means that we need more than just the ingredients in order to make it truly balanced. But until the iron smelting is a lot more, that's not realistic anyway. So let's just get some more miners down, and we do have rails now, and we are making steel a little bit at a time. It's a small amount. A very small amount, but it is an amount of steel, which is great. Okay. I'm wondering how to get steel into this whole situation, because that's the next thing that we'll need to do. We could move the stone smelting. I mean, everything's gonna have to move eventually. Are any of you actually waiting for anything? No, we are filled up. Which means that now we're just in kind of a holding pattern until everything is... Wait, we can't be. Are we? 50 gun turrets already. Hell yeah! Love to see that. We do have stone bricks on this belt already, meaning we could make walls here. Is that a terrible idea? 5 per craft, eh? Yeah, that should probably just be a dedicated... That should probably just be a dedicated build. We can make that down here. Let's do that. 4 stone furnaces for the purposes of walls and nothing else. Let's go. Gonna be fuel and ingredients and output. Yeah. That's fine. Okay. In. In. Out. There we go. Drop far. Pick up far. There we go. Alright, stone comes in here, fuel comes in here. So stone will come here, fuel will come here most likely. Are we exactly at the wrong place? Yeah. Okay. It's what it is, you know? No. Try again. There we go. Alright. Here we go. Like this. And may the spaghetti forever rain. Then here. And there. Stone bricks. Nope. Try again. Try an even more third time. There we go. There we go. Yeah. This is a thing. This is a thing for sure. Now, how much can you support? You can support... It's 5 per 16, doubled. Actually, no. It's 5 per 4. So about 1 per second is what this would make, assuming everything can keep up, which I think it can. Yeah, everything can keep up. Okay, so that means we need to consume 1 per second, which we obviously can, because these take 5 per half second. So it's as easy as just doing this and doing this. And I can... I could either fast inserter or I could just load. There we go. Now we're making walls. And I'm just going to let that run because we're going to need all of those. Because we will need to... Okay, iron saturated up the belt again. We need more iron smelting again. Which we can do. Possibly. We are making steel at a decent pace. That's great. Okay, let's talk about steel. While we're talking about steel, we need steel beams for rails, and steel plate for all of that kind of stuff. I think the best way is just to throw it onto our belt, onto our maul. Drink some water, thanks. You're right. You're right. I needed that. I was about to say you're welcome. Okay. The next thing is definitely rails. Stone and steel beams. How fast do these craft? Not very fast. Okay, so we're gonna want a crafter to be manufacturing steel beams for sure. Easy enough to do. Just like that. And, nope, try again. There we go. And a chest, please. Thank you. There we go. So now that'll handcraft steel beams for me at not a huge rate, but we can speed it up a little bit. There we go. Let's do like that many. And then we can use those for all of our rail crafting needs, and there will be several of them. The rail crafting needs, that is. So, now it's time, I think, to defend. We're going to defend the little base we have. And then we're going to start planning out the actual base. And I think the actual base will go... I don't know yet. We need to build a car and... Can we build a car yet? Music, please. Okay. Car. We should be close to car. Yes? Oh yeah, we're close to car. We just need fuel for car. And then car for car. Perfect. Okay, okay. We're making moves. We are making moves. We're almost taxed on this already. It's pretty crazy. Alright. Alright, stone mining is now taxed. A little bit, anyway. We are going to need more... we're going to need to find another stone patch. That's going to be necessary. Yeah, we are going to need to find another stone patch for sure. Do we have one on the map already? Oh yeah, there's a huge one directly to the north. What am I talking about? That's great. I mean, it's not that big. It's only 700,000, right? Yeah. This is only 50k left, though. Woof. We've really eaten through those resources, huh? Crazy how that happens. Man, the infrastructure required for making all this a thing is kind of crazy, actually, when you get down to it. Alright, let's grab some mining drills. We should have 50 of them. That was easy. I love that. I really love that. That's one of the cooler malls I've ever made, for sure. Okay, we're gonna want to make sure we're mining everything. Alright. Just one of those. And one of those. Just gonna get all the miners in place. To make sure we're taking full advantage of our stone patch here, which we are as of now. There. Alright, stone patch fully utilized. Or at least all of the miners are on it now. We've got some iron left, which is good. This little stone patch, I mean. We've got a ton of, not a ton, we've got 50,000 coal left. This is going to run out eventually, at which point we'll need to divert the other, oh, low power, immediately, okay. Boiler, please, and more iron for, we should just put steam engines and boilers on the pipe. We can't, because there's no stone. Okay, I'll craft my own boilers, that's fine. But steam engines, I would like to be made for me, please. Thank you. Steam engines, let's say we want... Well, we just want 10 on the belt. And then we will put those in here. Yeah, we can make 50 of them. Why not? I don't know if they're used for anything later, but... Yeah, mining drills are still... Okay, I'm just making sure this thing's still working as we're adding things to it. Man, that is cool. Assemblers, are you at 10 or 20? You're at 20, okay. So as I take more assemblers out, then it'll... Okay, cool. Steel is doing its thing. We've got 100 steel beams at this point. That's pretty cool. Okay, time to defend the base, as I was saying, which means it's time to design a little bit of a thing to defend the base. Now that we have fuel, actually, hold on. Do we have flammables somewhere? Yes. And flamethrower turret. Flamethrower? Flamethrower. Okay, we need 50 military tech cards for flamethrowers. Oh, it's a ways. It's a ways. We'll start the process, at least. Military tech. Military 2. Silicon processing. Advanced? Really? Okay. These take... Does that mean these take electronic components? Yeah, so these will need oil. Interesting. Okay. I would like flamethrower turrets, for sure. Those are important for our defensive strategies, but it's fine. We can always redesign. I just want to design a wall segment so that I can do what I do. What am I talking about? I'm losing it over here. All right. Defense. Steam turbines. Out of electricity. Yes. Steam turbines. We've made 1. Oh, now we've made 2. There we go. Okay, boiler. And then pretty easy to expand this. Are we out of inserters? Really? Wow, alright. Okay, that'd be a waste, I think. Let's put down one of those. And let's go grab some more inserters, because we are apparently out. That's easy enough to do. There you go, we have 100 of them now. I do like it. Alright, there we go. Our satisfaction is still... Really? Okay. Those mining drills are expensive when it comes to the energy, huh? Okay. What to do? What to do indeed? Because we need to... There... Either with that or with landfill. Not quite. Okay. We do have some landfill being built. I'm just trying to see where we're gonna... Also, our pollution cloud probably ballooned a lot, and we need to be mindful of that. Yeah, it is swelling quite drastically, which makes sense. So we're gonna need even more boilers. We'll start another boiler stack coming down this way, which requires stone. Okay, squeak through, essential mod there. Alright. Boiler, there's fuel researched. Love to see it. We'll have to take a look at that in a second. It might be more efficient than just the fuel processing that we've been doing. Alright, we're gonna go this way. Because we can do some weird stuff, remember. Like this. And pick up from there. This can be replaced with one of those. Okay, then steam turbines go off this way. There we go. And now we can just put another block this direction, which is pretty cool. And we'll see what we have to do on the other side of this in a moment. There's a few different ways we could route that. I'm just thinking it through. Steam turbines? 1. What are they missing? Small electric motors, which are missing copper cables, which are not outputting because there's too many of them. Increase the amount of copper cables, please. That's probably not a great solution long term. This belt is getting stacked up quite a lot. Okay. It's fine. You've made 3. Okay. The electric engines are coming around. They take a while, though, they do. Okay. I mean, that'll stack up over time is the idea. You can probably go down to 20. Not very much stuff using circuits in this mall yet. Mostly gears and motors and such. Still 81. Low power makes me... Because low power with combinators, I think they start to lose... Ooh. We might want to set that up on a separate grid eventually, because I think they lose the count, or can lose it. Look! My inserters! They have fished for me 40 fish! Totally forgot we set that up. That's fun. Alright, there we go. We're still not meeting... Really? 13 of them, and we're not meeting demand. Oh! Are we out of fuel? We are out of fuel. Not because we're out of coal, but because we are out of fuel. So, we need another fuel processor, but it might be time to look at fuel in the fuel refinery instead. So let's talk about fuel in the fuel refinery. Light oil, or solid fuel, produces 10 fuel. Okay, so this isn't a thing we can do for now. This is a thing for later. Soon, but later. Okay, a little bit of iron, please. Alright, and then we want to get that out of the way and put that there. A little awkward, but it'll do. Alright, now we've doubled the fuel output. But we might run out of coal now. Isn't it fascinating how this game is like, oh yeah, nothing really is going on for hours and hours, and then all of a sudden... let's put this here. There you go. Yeah, then all of a sudden, it just gets really fast. It gets to the point where, you know, you're doing a lot of stuff very quickly. And remember that we need to be cautious about our energy use here, because every one of those electric miners we put down costs more and more electricity. But we do need them because we need to process fuel, because we need to feed the steam boilers and the furnaces and all of the other things. Yeah, I did finish a this was a big project. Such a big project. Ridiculous. Okay. I don't think 50 is the right call for this, actually. The more I think about it, the more I think 50 of these is too many of these. Let's go with 20 instead. Okay. We've got another steam turbine, which I think will still not put us above where we need to be. Well, now we're lacking fuel is what we're lacking, so... 14 of them. We are going to need more coal. We're going to need more coal, and we're going to need to turn it into more fuel. Okay, there we go. Even more mining added to the line. We might need a third fuel processor here. Go here. Here. There you go. Output. There we go, even more fuel. Because you can see this was backing up, just like this one was. So we do have enough coal to warrant a third fuel reprocessor. And that is giving us 10% extra every single time. So that is something. And remember, this is at full bore. The factory is producing goods in the mall and researching with 15 labs all at once here. So this is the factory running at like its absolute most. What is glass set to? 30. Okay. Okay, we've got all of them running again. We are barely meeting our demand at this point. We could use another one, which we'll do once it's built. How are we doing on walls? We have some. We do have some walls. Excellent. Okay. So let's talk about chunks, because I think there's a way to turn on the chunk grid. There are chunks in the game, and rails follow the chunks. So we want to, any blueprint we make, we want it to respect the chunk boundaries. The reason we want it to respect the chunk boundaries is because we want all of our blueprints to incorporate rails into them so that we can, you know, use the rail system, essentially. So let's talk about it. Let's look at our rails. Rails are weird in that they only place every other. So as long as you're rail aligned anywhere. But every blueprint needs a rail in it so that you know where you can place a rail, basically, is the idea. So we are going to look at something like this. Loader. There we go. Because you can unload from a train like this. So we want any wall design to be able to incorporate this, basically. So this will be our... Oh, and we're out of belts here. Yeah, that's not the best. It's fine, though. Did I pick up those gun turrets? I did not. Okay, we're going to have to think about that then. So, let's just... like this. Okay. So... awkward. So this is our corner. Gun turrets can be fed ammo from a belt with ammo, which is great. Okay. And I kind of want to put some thought into the design of my wall, like aesthetically, as well as in case those get attacked, I just want them to have some ammo. Aesthetically as well as functionally, usually I just make straight walls that work really well but are kind of boring to look at. So let's get some walls and gun turrets and belts and all that sort of stuff, and we can start thinking about that. We are coming close to the end of the stream here. I had planned on streaming from 11:30 after the premiere of the video on the YouTube channel to about 4:30. So we're coming up on that time. But I do want to just get a little bit of a design going, and then we can call it. Let's get some of those and some of the gun turrets as well. There we go. All right. And we'll talk about the wall defenses. Also thinking about making the base like I'm having a lot of thoughts basically. So let's see. These have some range. So we want to be able to route a train between them and the wall, and I think I actually want them to go out here. That'll be the wall. So let's do the same on the other side using our train as our measuring post. Let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Interesting that that is not aligned, but it is aligned on this side. See what I mean? It's weird. It's weird stuff going on. So we want to go here, actually. And something like this becomes our corner. Could use some more rails just to see what's going on. Completed military 2. Alright, awesome. And really, we want it to be okay. That's the sharpest corner you can take. I do believe. Yeah. Okay, so that's the circle for the rails. And we're going to base our wall design around it. Because then it should be aligned to the chunk. In such a way that we can use railways whenever we wish, basically. Let's just draw in the straight lines here and see what we're dealing with. First of all, it appears that this and this are different. No, they're not. Just a trick of the eye, I suppose. Okay, good. They are square. That's good for my sanity. It would be a shame if they weren't. Okay. So if this is a corner, we need to think about the railway here. So this will be the corner of the belt. That's 1, 2, 3, and this is 1, 2, 3. Yep, that's the corner of the belt. Okay. And we can do one there, and we can do one there. There we go. And then we will also need to think about flamethrower turrets and how to work those into a design later. But we'll get there. Okay. First of all, let's make it too wide. Like that. And then let's bring it in like this. And that should be the corner section of our wall. Okay, great. And a train can drive there, which is great. I don't know what we'll use those trains for, but probably resupply for like outposts and things like that. Artillery trains, all sorts of things you can use them for. Ooh! First biters! Let's go get them. For the very first time, we are actually being threatened by biters. Which means our pollution cloud has gone to the point where... Yeah, our pollution cloud has grown to the point where we actually need to worry about defenses. So good that we're working on defenses right now. Give me 100 of those. Give me a bunch of those. Silicon processing is done. Great. We're kind of gunning through the researches here. We do have a car that we can make now, and we're heading towards military science. And then flamethrowers. And then we just need flamethrower turrets. And once we can make those, we should be able to set up our defenses pretty well. Crazy that it's been this long and that's the first fighter attack, though. Alright. So that means we need gun turret here. Ammunition, please. There you go. That'll defend that for a minute anyway. Okay. Now, I really need to know how to turn on the chunk boundaries, though. Let's talk about that. Factorio, chunk boundaries, if you would. Debug settings UI is what we're looking for. And it's apparently down here. It's F4. And then show interesting. Show chunk components? Oh, interesting. Looking. Blueprint grid? No. Tile grid? There we go. Alright. So here's our chunk. So, we can see that we've made a mistake already. In that it does not line up. So let's line it up with the chunk here. Okay, and then we need to move it over by 1. Like this? There we go. Okay, so that's the actual corner. But we want to move it in by 1, which means we need to move it up by 1. Like this. Because we want to be able to actually build our wall inside the chunk. Okay, here we go. Now that means that the corner of basically our base will claim chunks, chunk by chunk, is the plan there. So let's just do that. And that'll just help with symmetry, I suppose, is the idea. Let's go here. There you go. And then we need the belt. Let's lay out the gun turrets first. Should be here and here. How goes things? Things goes good. Thanks for asking, RJ. How are you? We're approaching the end of my stamina. But, that's only 6. That makes sense. There we go. Now it's square. That should be 7, and this should be 7. Ah, I see it. Okay, there we go. Now it's square. 7 and 7. Yes, excellent. Okay. Inserter, inserter. There we go. So that is going to be our chunk aligned corner wall. And we need a way to route pipes as well, because that's important. Let's look at the there. All right. Should be the way to do it. Like that, and then that'll be where we put our flamethrower turrets with those ones, which will be great. I don't know how well that'll work functionally, but I think it'll be cool. What the heck, guys? Rude! Ignored my turret. Attacked my stuff. How dare you? Okay. Alright. We're jamming. Ugh. Back to it. Here we go. Basically, then we'll have like little sub-chunk parts of the base for like each chunk that is not a wall chunk will be a productive space. That's the idea here. Okay. Alright. So that's, let's see. 1, 2, 3. How many are... How far across is one chunk is what I'm asking. 32. So we need this to go to the 16 mark, which it does. Perfect. That is one single half chunk boundary there. And then we can go like this. Perfect. And we can maybe build another one. No, we need more steel beams for that. Okay, that's fine. It's 2 past. There you go. So that'll be the corner. And we will want it to be chunk aligned, which I believe we can do. How do we do this? Snap to grid. Grid size 32 by 32. Grid position. There we go. Snaps to global grid. Here we go. And this is wall corner V1. Yeah, and then we can just... These perfectly line up. Look at that. So anywhere that the corner is, we just put the corner. Awesome. Alright, I don't like this song. Let's skip it. I'm not into trap, really. That's not my thing. If you are, no, you know, no hate, but not my thing. Alright. And then we actually want to redo that blueprint with the extra rails in place. And the flamethrower turrets would be nice as well. Okay, how do we build our military tech cards? We need plastic for those. So we're probably not doing that today, even though that would give us... turn off the tile grid. Even though that would give us the Oh boy, words are hard, guys. We need stone for more. Okay. Well, we have stone mining going. That's good. Yeah, this is why it's time to wrap up the stream, because my brain isn't working anymore. Lingually speaking. There we go. Okay. So this is our... Oh, and let us not forget, lest we forget... the most important buildings in the game. Aligned to a chunk. Okay. So now we can... Did that put in my inventory? Yeah. New contents. There we go. And that's our grid. And that means the corners would not have... that means the corners wouldn't have flamethrowers because of where I put the pipes. I think that's probably fine, but we'll need to look at the range and the dimensions of the flamethrower turrets, so for now we're saving that as is. Okay. And I guess I've chosen this as my first chunk, so let's build our next thing here. Turn on tile grid again. And then it'll be... I think they're 2 wide, but they could be 3 wide. I'm not really sure. Either way, I'm going to leave enough space. I'm just going to put this on the edge, I think. One less, so that this can happen within the chunk boundary. There we go. Kind of want to put another one in here. Like, if this was 3, I'd want this to be 3 as well. And then this could be like this. If it's 2, it changes things, though. Does that make sense? Inside? Something like that. These are on the outside. Which is doable like this. Means these aren't all the way to the outside. Which makes sense because we want this on the outside. Ah, there we go. Okay. So then this goes here and here. There we go. That is how it should work. Something like that is going to be the formula for the wall. And then I don't want it to be just straight. That's what we wanted to avoid. So... Okay. Should be... It's 12, so that's 13, 14, 15, 16. So that should be 12, 13, 14, 15, 16, 17. This is the edge right here. So how does that work? What if we made like a little battlement in front of each of the turrets? That might be interesting. Like if this is the turret, then this goes out like this. Like that. I don't really know. And that encroaches into this. No, it doesn't. Okay. I think we'll have to come back to this with fresh eyes. I think I have reached the point in the day where I am no longer thinking coherently, and any amount of planning here is just kind of wasted time. So, let's see what we're going to do here. I think we're going to raid somebody, first of all. Let's see who else is playing Factorio out there on the World Wide Web. And we'll go from there. Can I just go to Twitch, please? Thank you. Thank you. Browsing. Factorio. Let's do it. Alright. It's hard because I don't know who's good. Oh! I didn't pause the game and... Oh, it's just a meteor. Just a meteor. Okay. Turn off the tile grid. Alright. Whew! Just a meteor. That scared me. Maybe we just do straight walls. After all that, and the interest comes from, like, you know, the way that we build behind them rather than the wall themselves. Maybe. We'll figure something out. I'm gonna save before something terrible happens. And now we're paused, and now I can browse Factorio people to my heart's content. Let's see. You guys following anybody who's live? Smaller channels, preferably? Not seeing anybody for Factorio. Maybe Dave the Diver? Not really seeing somebody who sticks out to me there either. It doesn't seem like there's anyone really online who yeah, we're gonna call it. Friends. Thanks for bearing with me while I have a little mini stroke there. I appreciate each and every one of you. You are amazing. Thank you so much for hanging out today. If you haven't already, I'll drop the link to the recap video from the last stream in the chat. It's a pretty good one, I'd say. I think it turned out really well. So check it out if you haven't already. I'll be back tomorrow evening playing Baldur's Gate. tomorrow night playing Baldur's Gate. We're taking the day off on Saturday because I'm going to a tournament at Boise State University. And then we're taking the whole week off, Saturday to Saturday, because it's Thanksgiving, we've got family in town, yada, 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 yada. If I have time to do like an impromptu Baldur's Gate stream or something between now and then, maybe I will. We'll see. I'll let you guys know in the Discord. Be sure you're in the Discord if you're not already. Here's a link for you. That is an important place to be for all the stuff and things and conversations and notifications, etc., etc., etc. Okay. I think that's an outro. Is that an outro? Is that an outro? Is it an outro?